All right. Welcome. Welcome to the Game Engine stream. Let's see. You know what? I've been guessing which stream it's been for like the past like 3 streams. Let me make sure which stream it actually is. Okay, it looks like it's the 63rd stream. So welcome to the 63rd stream. It's a Wednesday today, January 8th. Let me make sure I got all my stuff ready. Board. Okay. Alright, so let's go check on our updates, which there are none. Kind of per usual nowadays. But yeah, there's not really much to talk about. Right now, I'm still working on particles. After I finish the particles, I'll get back to working on the UI. Still just doing this. I guess I might be doing particles for like 2 days. Or like today and tomorrow. We'll see. Last stream was a lot of just bug fixes in the particles and whatnot. So today, I want to start off by adding some actual new features to the particles, since I've kind of already dealt with a lot of the administrative and bugs and whatnot things with the assets. So all that garbage is done, as far as I can tell. So yeah, we can move on to, I think that, okay, the first thing I'm going to do is inside of my EmitterConfig, the configuration for whatever emitter is currently being used, I already have a beginning size and ending size, as well as a beginning color, ending color, right? So the first order of business is to get those values actually working. That should be pretty easy. They're just lerps. And I might configure using maybe a certain, how do I say, like ramping up and ramping down equations for the lerps, I suppose. Oh, let me switch this really quick on the music. I'm gonna start up on here, like starting this track. Yeah, so yeah, we'll get the color ramp working with the linear interpolations. I might add some different curves to it, so that would be fun. And what else? Yeah, like with that, I'll add some different easing curves from that website I think I showed last stream or so, but I'll show that again. And then after that, we'll integrate the emitters into the scripts, so I can spawn emitters at any place I want to. Maybe give them like a lifetime, so that'd be cool. And yeah, I think that's my checklist for today. So let's go ahead and get into it. Alright, so let's check the progress board really quick. I think I already talked about what I did yesterday. It's mostly just bug fixes. Today is still a particle system, so nothing changed about that. Probably should be adding more specific things. That's what I usually do here, but I've been kind of lazy about doing this progress board, so when I finish the particle system, I'll get back to getting more specific. I guess I just wanted to think to myself that this particle system thing would be shorter than it actually is. But yeah. Alright, well, I guess without further ado, let's get coding. Let's get started. Alright, so let's run, let's see where we're at. I think I left off at a pretty good spot last night. I was really tired towards the end of that because those bugs were killing me, man. So today I'm praying for less bugs. Huh? Let's hope for that. On your best behavior. Yeah. Nature. All right. So yeah, I think I dealt with all of the asset things. You can delete these particle systems now. You can transition between scenes. Should be able to modify an emitter. Interesting, this is a difference. Or is it the same? Oh, I guess it's the same. Yeah. I was just closer to it here. Alright, so yeah, these don't work. This does nothing. So let's get these doing something. And I think maybe the first order of business with this is just to get it working in a simple lerp context. And then once I get it working with a simple lerp, then next thing is add some different easing functions. So one thing at a time, right? Let's get it working period first, then we'll go on to easing functions. This is closed, hopefully it doesn't crash. Okay, it didn't crash, good. Okay. Alright, so let's implement these lerps. So let's go to the particle service. Oh, my bad. Got stuff falling and whatnot. Alright, so I think this is relevant either in the on render or it's in the... Actually, I don't know. Am I presenting a color in the particles? Let me see. It looks like that's a big no. Which is fine. So that means I'm probably doing this on render then. Okay, yeah. So that's fine. So yeah, I must be submitting a different color for every particle. Like that can't be efficient. Huh. You know, I should profile this particle system soon and see what's going on with this. Because at some point I gotta start doing more like batching these things instead of like... Because I do have a batch renderer, but the submission is like per particle, which is not ideal. Yeah. Okay, anyways, we're providing the position per particle. Okay, we're translating, providing a matrix for each one. Is that ideal? Doing a matrix calculation per particle is kind of wild. Alright, well, whatever. I'll worry about optimization later. Creates, submit a color based on the current linear interpolation. On the current interpolation. Okay. So to do that, all I have to do is just submit a color, right? Which is basically just this code. We're not aware what the buffer is. So let's submit this as separate bits, right? We'll kind of do that. Okay, and then local buffer, right? We're gonna do, I think, S particle context. This is a printer, right? Yeah. We're gonna do the particle rendering spec. This is object and buffer. Yeah. We'll submit the shader along with this. Okay, so now we just need to modulate this color based on a linear interpolation. So I believe there's a GLM interpolation I can use. For defaulting white, I don't want that. We're gonna do GLM lerp or slurp. Okay, some crazy names. Okay, how do we use GLM lerp again? Okay, he's taking quaternions. What? Yeah, I'm assuming there's like you know what? I'm gonna make my own for this. Okay. Well, let me go look at Cherno's implementation of this really quick. bin int sandbox source. Yeah, it's in the implementation file. And then we'll look for alert. Okay, that's pretty simple. We're just providing color in, color end, and then the actual value, which we calculate like this, which is going to be pretty similar to what I'm doing. Yeah, particle lifetime. Yeah. All right, so let's copy this. And of course he's doing this per size and per color, which I guess is fine. Let's close this. Okay, so that should just work, right? So we're gonna do particle dots. Oh, no. Not particle, my bad. We want emitter. Emitter.mconfig. And color begin. Maybe I'll find a way to make this more efficient. Points. Okay, and then life. Okay, so now we just need to figure out what the life value is going to be. And then this is basically just going to get tossed into here. This lerp provides what? Because this is like a color. Oh, this gets turned into a math vec4, yeah. Oh, yeah, this is a math vec4. So I can just toss this directly into here. So let's do this. And then this is going to be tossed right here, right? And then this is just incorrect because we need a value. So if I did like 0.5f, will this work? No instance of template function alert matches the argument list. Oh, is it because it's really vec4? So yeah, I'm gonna write this in my own little library, so I don't have to do this. What? No instance of function template glm matches glm vec4 float. There must be something he's including then. Let me go back and look at his code really quick. Is it this? Constants, huh? I'm not gonna keep this, but I just want to see if that fixes this issue. Oh, it does. Okay. I guess so. Yeah. I'm gonna write my own linear interpolation function. Let's start doing that right now. Well, okay. Let me go back. Let me just put this for now, and then I'm gonna do a heavy to do. Remove this for the love of. Yeah. There we go. Cool. So. Alright, so this should now work. It's always 0.5, so let's actually make this value. So for a particle, we have, let's look at this definition. So the value you feed into a linear interpolation should be a float between 0 and 1, like normalized. So I provide start time and end time. Oh, okay. So start time and end time. Right. Start time and end time. I'm just thinking really quick. Subtract the end time, start time from the end time, you get the distance between the two, right? And then you divide the current time by the distance, right? Yeah, I think that's what you do. Okay. So that's not too bad. So we're going to do a little calculation. Calculate lerp progress value. Be a float progress. It's equal to, or we'll do this. So it's going to be particle dot start time or end time minus particle dot start time. So that'll give you the distance, assuming that end time is greater than start time, which it should be in all cases. If it's not, that would be weird. I guess I could put in a cert, but yeah, whatever. That's, I'm sure it's fine. And then divide. These are assumed to be floats by the current time, which should be in between these two, right? So let's be very clear here, since division, I think, the higher MDAS order or something. Let's see. Okay. There we go. And then we'll just feed in progress. Also, I don't know if I'm feeding in the size of the particle. Probably should do that, huh? So let's bring this linear interpolation value up. Alright, render the particle, sure. So I'd say this part goes down. Render the particle. And then this flushes the actual buffer, right? So calculate the third progress value, and then what we're going to want to do is also do a lerp on the sizes. Yeah. I'm trying to think how I want to do the sizes. Let me just look at, I mean, I know how to do it, but I don't want to start making up code right now and then get it wrong. So let me go see how he does it, because I know it's just like a, yeah, you do the translation first, then the rotation, then the scale. Yeah, I think I remember that order. And then of course that means that this is applied first, this is applied second, this is applied third with matrix rules, right? Because they go in reverse. Okay, and the size is generated from this, yeah. So let's go back. All right. Okay, so then let's move this one over here really quick. All right, so we'll do gln translate times size times size, which is not a thing currently. So let's go make that a thing. This is being fed directly in. But this one, calculate the size, interpolation. We're going to be float size equal to And this time we're going to do config.m size begin. It was wrong. Oh, because we're converting it to the wrong thing, yeah. Yeah, we don't need to do this, actually. I'm pretty sure we don't. It's providing a map, because it's a type alias, so we should know what it is. Yeah, so actually, yeah, we don't need to do this, I'm pretty sure. We don't. Color end, so then we're going to do size end. And what's wrong? Oh, right, it's supposed to be map vector. Okay. Oh yeah, okay. And then we do. Oh yeah, I can provide size values. Well, this size value is a float, right? Oh no, it's a vec3. Wow. So I can make it more forward time. That's kind of cool. Yeah, I want to see that actually. I guess we'll do size on x. Size on y. And you know what? Why not? We do size, that's it. Z. Let's see how that works out. And of course, the linear interpolation. I can get a vec4, so that's cool. Yeah, I'm gonna profile this too, maybe with like a high number and see how this ends up. But I think this code by itself should work. So now I think if I specify like different colors, we'll get like interpolations between them, which should be fun. Yeah, hopefully I don't get like a huge performance dip because of this code. I don't know. We are doing all this linearly. Maybe a good thing I could do is at some point when I get the GPU code. I mean, for now, like I'll be limited by the CPU with this calculation, but maybe at some point when I get the compute shaders, I can speed this up by a lot. Because it's a lot of parallel coding. So yeah, let's see. Syntax error. You are right. You are correct. I'm running that as a string, huh? The A color? I wonder if that's an issue or not. Again, I gotta take a good hard look at my rendering code at some point. Because yeah, this linear way that I'm doing it is not it. Why? It is not it. Okay. Okay. Okay, well that's not working. Dang it. Oh. Wait, what? Wait, what? Okay, that's got some visual artifacts, definitely. If I set this to 0. Are we only using the... Why are we only using... Wait, did I... Okay, wait, no, I think I know what's wrong. Did I really? Wait, no, it is color beginning, color end. What's going on there? Maybe I'm calculating my lerp incorrectly. Okay, let me see what's up with its progress. That might give me a hint. Okay. So let's... Okay, yeah, that's like a normal end time. Current time. Wait, what? (1.21) minus 0.21. That is the lifetime, right? Lifetime divided by... Oh, wait a second. Okay, wait, no, I think I know what's wrong. Yeah, I think this calculation is a little too complicated, not gonna lie. Yeah, but that progress value is messed up. Okay, start time is 0.501. End time is 5. This is 6. Okay, so what do we get? You should get like close to 0, right? Yeah, there we go. Okay, so let's try that. That should be correct. Yeah, that's some... Yeah, that's some Z buffer stuff going on right there. That does not look pretty. Let's see them. Let's see. Okay. Yeah. It's kind of cool though. Let's do starting size. Let's do like 0.5. Wait, what? This is 0.5. And ending is 0.5. And then, oh yeah. 0.5. So let's do like 0. It's kind of cool. Let's do like 0.2 and 0.2, I guess. Okay, that's kind of cool. And if I go back, it should just be showing this. And now when I go back here, yeah, so let's go ahead and save this. Nice. Okay. Yeah, there's a little bit of like Z buffer issues going on, but I can deal with that, honestly. But yeah, that's kind of cool. Okay, another issue I think I wanted to deal with though is when I mess with the buffer size though, I want it to reflect immediately, but it doesn't. And I know how to fix that. I just need to respawn the emitter every time I change it. But yeah, this is a cool little effect we got going on. Yeah, I know how to fix it. Let me go do this real quick. And there's some invariants I can probably cache here as well before I start doing this. Yeah, at some point I will upgrade this to like a GPU particle system, and then I can render a lot more particles. That'll be nice. All right, let's go address that issue I was talking about. I believe it's in the editor, the windows and the EmitterConfig. So whenever we modify our properties, we need to do something additional. So on modify, any of these basically, we just need to call an additional function. And I believe that function's in the windows. Let me check. If config and clear. Okay, yeah, it's basically just this. So we're gonna do s EmitterConfig window. Yeah, so we're gonna reload this basically whenever we make a change to anything, really. I mean, I guess the main one that would really need some changes is just the buffer one, but I'll just do it every time and see how that looks, because it's only one, so I don't think it's that big of a deal. So unmodify begin and size and lifetime, spawn rate, and then buffer size. Okay. So now we're reloading every single time every time we modify. Alright, and I think I might as well just add some easing functions in. So yeah, I guess I might as well add that really quick. Okay. Okay, kind of cool. Spawn rates. Okay, so if I modify the buffer size to 10. Okay, and then change the spawn rate to like 2. Yeah, so basically 2 per second. That's pretty cool. Let's change the buffer size to like, and then we'll do the lifetime to like 15. Nice. if I go back, this is still pretty simple. But then if I go over here, and then go ahead and just do save this, go back. Yep. There we go. Okay. Yeah, I mean, as like a basic implementation, that's pretty good. Yeah, there's like a ton we can do with this. You can make them spin, you can make them, you know. Nice. I'm just admiring the colors right now, honestly. Let's try... At some point I'll add like a color picker to this. Actually, maybe I should soon, huh? What is the ending color? Yeah, what is this color turning into? Yeah, it's turning into like a bluish. I mean, that makes sense. It's like blue. Yeah, you can get kind of a sense of scale with this too. Nice. Okay, yeah. I'm pretty happy with that. Alright, so now that that's done, let me go ahead and commit really quick. Nice, that was a pretty easy change. I think... Yeah, I don't love this. You know what? Let me add some easing functions in really quick. And let me research like a basic linear interpolation. Alright, where's the basic interpolation? I guess they don't have it. I mean, it's pretty easy. Pretty easy equation, right? Just add ChatGPT. I know the equation. Okay. Yeah, can you give me the basic linear interpolation equation? Oh, this is for like an X, like a 2D interpolation. Interesting. With sorry, in just one dimension. You are using X and Y. I just want X. Does this thing not know what I'm talking about? The function should be given. Sorry, let's describe this word. A beginning X value and ending X value, and a normalized float between 0 and 1. It should get an interpolation between the provided X values. There we go. Yeah, I was about to say. It's just this. Okay. I just couldn't remember what it was verbatim. So let's go back. And let's go ahead and add an interpolation equation. We'll put this in the engine as well. I'm wondering if it should be in utility or in core. I'm gonna say utility. Seems like utilities have a thing. New item. Interpolation.h. It might just be a header file only. Well, let's see. I'm gonna paste this in just maybe not. Okay, let's go find something simple I can grab, like this one. This one has an implementation file though. But yeah, basically just this. Okay, so let's. Interesting. Interpolation. Linear. And then do I provide 2 floats? I guess I can interpolate between. What is this? I'm crazy. What the hell? Oh, okay. Traffic notifications on my phone is kind of annoying. So I'm going to have different easing functions here. So I'm going to start with linear, and then we'll start with floats. Just keep things simple. Initial, or start, points, floats, endpoints, and floats progress. And I can probably just do this entire thing right here. So basically, pretty easy function. So we're just going to return. What was the function again? It's basically this. And you give this to me in C++ code. Okay, yeah. That's what I want. So let's say start points. Start points. Yeah, again, don't know the terseness and things. I like the names being specific. X1, X2, no, just... There we go. Start point plus endpoint minus start point times progress. Okay. Let me ask if, how can you give me this for a vector 2? A vector 2, and float progress. I mean, yeah, right? I mean, I don't know. That makes sense. Just do it for each component. All right, let's include hash, include Cardano, core, no, wait, no, it's math. Wait, actually, maybe interpolation should be in math. Now that I think about it. Let me go see what the math library's got going on. Yeah, these are just like global functions. Parts of this just works actually. You know what? Let's move this over really quick. Because math.h includes this. Let's do like let's move this over away from utility, because yeah, That actually doesn't make any sense there. Let's do this. We'll get rid of this. Interpolation. Let's see. Linear interpolations. Okay. Let's get rid of this. And yes. Alright, so let's do linear. And we'll just do some overloads for now. So back to math. Back to and progress. And yeah, we'll bring in a math vector in this case. Back to. Yeah. Okay. Let's put this right here. Actually. And then we're just gonna do this, right? I don't know. It's gonna be start point.x, endpoint.x, and start point.x. Minus progress. And then we're gonna comma this. And it's gonna be the same thing, just with blank. And then just return that. And then we'll just go again for event 3 and event 4. I mean, just duplicate it and then do Z, right? Yeah, I don't know. Okay, yeah, sure. So we'll just do all the variants of these. And then just do W in this case. Okay, so there we go. We got some simple linear interpolations. So yeah, and this function just being global like this is just so weird. Why did I do this to myself? wonder if I should. You know what? I'm gonna put this in the implementation file. You know. Just as a rule, it's the header file I use it to read. I mean, I'm in C++, I might as well use the functionality. Keeps my, how do I say? Keeps my compilation times down if I change things. Okay, yeah, then there we go. Okay, here we go. So nice. So let's go back to vertical surface. And instead of this, we're going to do math interpolation here. A little extra writing here, but I think it's fine. Math here. Oh, in interpolation linear. Okay. Yeah, I like these things being like this. There we go. I think that's a little easier to read. Okay, and now I can get rid of this thing. Hopefully it's not too much slower. Let's see. Alright, and then I might push, and then I'm gonna see if I can add all the other curves in really quick. It's just one big commit. Also maybe add some enums or something so I can specify which curve I want to use, and then add a function for like maybe a switch statement for using the correct curve. Yes, that does a lot of, yeah, because math is included in literally everything, so we'll have to recompile. Oh, my back. Let's see. Yeah, I guess while it's compiling, I'll look at the interpolation curves really quick. There's quite a few of these. These inbounce. Yeah, I want all these. These look fun. Maybe I can profile these two and see which one's the fastest. I mean, obviously, this one's probably going to take a little bit of time. Maybe not, I don't know. So we'll see. Yeah, and then once I set up these linear interpolation curves, I can just use them everywhere. So, kind of a one-time fix. Oh yeah, there we go. So that's working, I think. Let's profile this. Let's see if this is a lot. I don't know. Hopefully it's not eating up a bunch of performance. What's this doing? UI render. So we have on UI render, viewport panel. Yeah, viewport panel is doing the most. But I mean, we're staying below like sub 4 milliseconds. It's not too bad. Yeah, we're not doing too much, so that's good. Okay, let me just close it for now. Yeah, if you look really close, I'm sure the Z stuff doesn't look great. Yeah, it doesn't look amazing. Oh well. Okay, well, yeah, that's good. Okay, let's go ahead and push this code. And then we'll start messing with these interpolation curves. Load. Okay, so resets emitter instances when modifying emitter properties in EmitterConfig properties panel. What else? Oh yeah, okay, so in math we start creating interpolation class, static interpolation class, start adding interpolation equations into math.h/d. And map in the particle service. Let's go see. Oh yeah. So use linear interpolation for color, particle size, and color in particle service. .cpp. So the main thing is get colors, particle size / colors, interplay for emitters. So yeah. Okay, so the next part is gonna be a lot of like, just a lot of work, I guess, but it should be worth it. Let's switch over to Soulstone. I like this one. All right. So the interpolation, the linear interpolations myself, like I did that, so that's fine. Okay, let's start adding the rest of these. Ease in sign, ease out sign, ease in out sign. I mean, maybe I could do like ease in quartz, ease out quartz. What is circ? Oh, cool. So they do this all in one. Nice. I might be able to cache some things with this. Wait, so these ease in and out functions, right? It's going between... Oh, wait a second. Oh, so this returns a float. That's between 0 and 1. Oh, I got you. Yeah. Oh, okay, I got you. Yeah. I think I understand what they're doing here. So they're just taking a single number and then they're returning that. Okay. Sure. And the returned value is just a number between 0 and 1 as well, but that one to be used in between the two numbers, I guess. So it's not directly interpolating two numbers, this is providing a value. Okay, let me see if I can get this to work though. Because again, this takes in start point and end point, right? And interpolates, like sure, right? I'm just gonna think for a second. Start point, end point, and then progress. Wait. Come on. Okay, I think I understand. So basically, this progress bit that we're multiplying with this whatever value that we're doing, right? We need to calculate this. We need to take this progress, put it in here, and then the output will be multiplied by this. That's what's going to happen. So let's start with, I'm going to put that page on my other screen for a second. Alright, so it's basically this, right? Yeah, linear is simple because it's just that, but let's, okay, this one is ease in sign. Oh, wait, use this for a second. ease in sign. Ease in. And then what I'm going to do is I'm going to take the link to this and paste it right here. And then what I'm going to do this is linear, which is fine. But this I'm going to take and put here. And this is going to be ease in. Okay. And that's basically what we're going to do here as well. And basically it's going to be the exact same as this, but up here I'm going to do a little like helper function. So it's going to be inline ease in sign out, right? And all this is going to take in is a float for progress. And then we're going to return a float for the like output, right? I don't know if the compiler respects this inline nowadays, but I don't know, I tried. So then here is where I paste in that function. So let's go back to here, right? And then here, we're going to do cosine. So SED cosine. And then SED pi. Is there a define for pi somewhere? Get pi in C++. Use math defines. Is there a cleaner way of doing that? I don't know. I'll use that. Okay. Okay. Well, I have. Okay. I'm looking at the where to get pi. SD numbers. There's an include called numbers. Interesting. Let me go to my PCH really quick. I'll add it. I mean, I am using C++ 20+, so I might as well use all the features. So let's go to, where's my PCH? Yeah, hash include numbers. Oh, you can even convert it to like your preferred type. That's kind of cool. What's pi v though? Press. Is the fastest. I guess I can do this on here. Let me go pull this really quick. Is the fastest cosine for C++. I mean, I'm sure there's like approximations people are doing, whatever. It's way faster. This guy's trolling. What? X is close to 0 for approximately 4 to X. I mean, just like, which standard library thing do I use? Which standard? I'm not really like trying to write by my own right now. I mean, if I have to come back and it becomes like a issue for me, then I'll come back and make it faster, but I just want to throw something in so I can move on. Which standard library, which C library cosine function is the fastest? General usage, but it's typically leveraged. Yep. Okay. C math, in most cases, tricks is good. Okay, yeah, you know what? Let's just do cosine and call it a day. Okay, so then use this. This gives us the ease in calc, and all we have to do is just basically just take this in, right? But instead of progress, we're gonna do ease in sine calc. Progress. And then, of course, here we're gonna cache it. So we're gonna do this. We're gonna do it twice for no reason. Oh, let's skip all this. Okay, and then we're gonna do floats. Ease calculated progress. Or I'll say, yeah, ease progress is this. Just ease progress. Ease progress. We're assuming it's the same for both of those, so we'll just do that. Make our life easier. And then yeah, just move on with this one. Okay, I'll go ahead and toss this up here as well. And then we'll go here, and then we'll go ease. And then of course we'll go with this. Okay, easy as that. Okay, and then rinse and repeat for all of these. So let me put a note up top here that note the easing calculations were mostly found here. There's a lot of like code for this, huh? Let me see. Whatever. We'll just do it all. It's fine. So ease out sign. So find ease in sign and replace it ease out sign. And I'm assuming this actually links to the correct thing, right? Oh, it's spelled wrong, okay. Or maybe it is... I don't know, whatever. So this is lowercase. Alright. And then when I go here, and paste this, ease in, we're just going to replace it with ease out. Okay. And then let's get the actual equation this time. So it's this, so it's ed sign, this would be progress, and then what is up with this? Like what? V. Let me look at the std. Make sure I'm doing this right. Pi v versus pi. Let's see. std numbers. So what's up with this? Not a regular plane. A primary template for okay. Wait, what is the underscore v for? Wait, pi underscore v versus pi. Numbers. Maybe someone who explains this to me. Variable templates. Oh, so in these cases you specify the type. Okay. Okay. Sure. Okay, well, yeah, I guess that's fine then. Is that what they mean by underscore v? Interesting. Do 2.0f, right? What is this other one? I'll make this a float by default so we don't have to convert anything. Ease out sign calc. Oh, was that it? That was the whole thing. Okay. Nice. And ease in and out. ease in out sign. Okay. Ease out. Ease in out. Ease in out. I'm assuming this opens up that link. It does. Good. All right. All right. And then let's head over here. Yeah, I'll probably be doing this for maybe like an hour or so. Find ease out, replace with ease in out. And of course, we change the equation, so it's going to be, where is it? Oh, this one. Okay. Progress. This is pi. Okay, I think it's good. So we got these first three. Now we got to do all the rest of these. Let's see. All right, I'm gonna use the restroom. I'm gonna be right back. Okay. So I'm gonna switch over to some chill hop really quick. All right, let's keep going. I'm wondering if there's a way for me to write this out, because it is very like it would be very easy to parameterize this and just trying to figure out how. It's basically just this calculation that's always different. Let me ask ChatGPT. This is like something obvious I'm not doing. Is there a way I could make this code more reusable? Or so I don't repeat myself so much with this code. Yeah, there's just something obvious I'm not saying. Wait, what is this? I'm confused. So interpolation ease out sign, huh? Oh, okay, so we're providing like the function we're using for the easing function there, and then yeah, I suppose, yeah. Isn't sometime any pizza? So we're templating the actual functions for the types. That's not really what I care about, I'm gonna be honest. Also, this is specifically for the sign function. Well, this is easing function, right? And then they're providing the function pointer for the easing function. Yeah, I suppose. Yeah, you know what I could do actually? Yeah, you know what? Wait, let me try something. Oops. Let's see. So static float. Interpolate float. And then we're going to take in basically this, right? And then all this is going to be is basically just the linear one, right? Let's see. Okay. And then all we have to do now for all these is return interpolate. Oops. And then passes in. Of course, we'll get rid of these. I said misspelled this. And then, yeah, we don't have to keep repeating ourselves. Yeah, okay. Or, you know what, even better actually. I mean, I'm just redoing the same function. So, I could just... Hold on. Let me come up here. This isn't required actually. So, for the ease and sign, all I really gotta do is just call linear and then the start points, end point, and then this. So wait, this. And that's it. Yeah, easy as that. That makes a lot of this stuff I don't have to keep repeating over and over again. So that means here, I can do linear. Yeah. Yeah, actually, these are all the same. Like that. Okay. Yeah, that makes that a lot easier. here. Okay. So linear. And of course, if I want to template this, I could template it if I wanted to, but it's fine. We'll just do floats now and then go from there. Yeah, there we go. So now we're just providing this externally, and then yeah, it's pretty simple. I like that a lot better. I was like, I'm pasting way too much code. All right, let's keep going. He's in quad. Okay. Okay. Replace with quad. Actually, let's do this. First, we'll replace sign. The bigger ones are sign. Quad. Okay, now we'll find sign and replace it with quad. Oh, no, it's doing this. Okay. Okay, let's see if this opens up anything. Okay, that does open up the right one. Okay, these look like they'll work. So let's go down to here. And then we're just gonna go all the sign ones. Find sign. Quad, yep. Okay. Quad looks good. Of course, this is messed up, but I'm gonna replace these in a second. So now we just need to replace the actual equations. Quad is, oh wow, very simple. He's in quad. Yeah, I'm learning something kind of new too with this. That's cool. So quad is just this, which is just progress times progress. There we go. Oh, ease out quad. What is that? Okay, a little bit more complicated. I'm doing 1 minuses for everything. Progress, and then this, and this will be non-0fs. Okay, ease out quad. Okay, then ease in out quad. Let's go check that. Okay, this one's a lot more complicated. Holy crap. Alright, so everywhere I see X for all this. F, and then everywhere I see a number, I'm going to put a .0f. So I don't have to do any conversions or anything. Okay, and then we have std power. Okay. Yeah, that should work. Yeah, this is still a ternary, so that's nice. Alright, there we go. Now we got all the E's out quad pretty fast. Move on to cubic. Alright, so we got 2, and we're gonna do 1, 2, 3, 4, 5, 6, 7, 8. 8 left. Find quad, replace with cubic. Okay. Let's check if this actually opens up something. Oh, it does. Okay, cool. I think that's all I had to do there. Yeah. Okay, let's head over to the quad one then. We'll open up all the quads. Quad, replace with cubic. Okay, yeah. Pretty easy. He's in cubic, calc. He's in cubic. Okay, so now let's get the actual equations for this and I'll put them together. Cubic is just cubic, yeah. E's in cubic is just that, which is very nice. Yep. Alright. E's out cubic, of course, is going to be a lot of minuses and whatnot, and yeah, minus powers and okay. So for all the numbers, of course, we're going to do .lf. Okay, it's going to be progress, and then we're going to do std powf. What does powf do again? I mean, yeah, sure. Okay, and this one in out cubic, of course, is complicated as hell. Alright, okay. This, I guess this is how the equations just happen to fall. Okay, and then of course this is LF. Alright, and there we go. E's and out cubic. Words. Chord just is okay. Yeah, chord is wild. Alright. going 4 times now. Make sure it's open sub. Yep, that works. Alright, let's head over here. And just keep going, I guess. He's in cubic. Yeah, there we go. Alright, let's find cubic. We're going to change it to quartz. Yeah. Type that twice on accident. Alright, let's replace the functions themselves. So quartz is going to be, I mean, this is going to be another times progress. I'm looking at it right now. That's all it is. So let's do quartz. Okay, is going to be basically this, which I mean is 1 minus. I mean, the only difference is just this. Really. Yeah. Okay, and then yeah, this one is wow. What a function. What happens when you let polynomials go crazy? Okay, and then execute. Oh yeah, I think that's it. Go back, make sure I'm not breaking anything. Yeah, it looks good. Good. Quartz. Am I at least at half? 1, 2, 3, 4. Okay, let's get one more and then I'm gonna take a break. And then I'll get the last 5 real quick. Quint? Why is this necessary? Yeah, it's just times 5, okay. Just gonna keep going up, I guess. One, 2, 3. Eight. Right, pretty easy. Words. Quit. Okay. I think interpolations probably don't need to just be in the math section. Actually, I'll probably just put it in its own header file. Yeah. All right, let's go. Ease out quint. It's just 5, right? Yeah. Okay. Let's see what the differences are for this one. Quint. Zero point 0.5f times 16. 1, 2, 3, 4, 5. 5 minus power negative 2. 2 plus 2 to the 5 divided by 2. Okay. That looks the same. All right. Okay. Yeah, so I'm thinking maybe this doesn't need to be everywhere, so I'm going to make a separate in the math section. Interpolation. And then interpolation. And then here, I'm just going to take this whole class and move it out for a second. Because it doesn't need to be everywhere, to be honest. And then we're going to do namespace Argano math. Alright, we don't know what these are. Yep. So we're going to do hash include Argano math aliases. There we go. So that gives all these types. And then here we're just going to take all of this out. I think I have to include kgpch. Default. Namespace. Math. Paste these here, and of course we need to include the actual header files, so I'll include core math interpolation. There we go. And then I believe in where is it? Wherever we're doing this actual interpolation, I think we're doing this in particles. We need to include interpolation. There we go. So now interpolation will be included everywhere by default, so we can just optionally use it depending on the needs, right? Because this is kind of turning into like a big header. Okay, I'm gonna take a break real quick, and I'll come back and finish up these interpolations. Maybe add some, what are they called? Enums, right, for choosing which interpolation you want to use, and then I can go from there, right? All right, so I'll be right back for like 5 minutes. Okay, I am back. Let's continue. So I'm halfway done. So let's just see if I can finish this out. So we have exponential, or expo is the next one. So wait. It's expo. I'm sure this opens the thing, right? Yep. Alright, let's come down here. Ease out quints. Ease out, ease in quints. Quints to expo. Right, and let's go take a look. Yeah, this is a different function entirely. So ease in expo is this. I guess it's like this. Which, yeah, no, not that. So if progress is equal to 0, return 0. Otherwise, we do the lf and let's turn all these in floats. And of course, this is 10. Let me make sure there. One of this. Okay, so I'm assuming this is base 10 type of deal, right? Make sure I didn't break anything. Ooh, I gotta be careful with this though. Okay, I'll just set like an arbitrary value. I'll say it's less than. Progress is less than 0.0001. Right. And to return 0. I don't like imaginary numbers though, or magic numbers. So say const floats. Okay, what do we call that? Tolerance, open tolerance. 0.0001 f. Tolerance. There we go. Okay, I'm cool with that. Okay, so more of this, I guess. So this one, I'm going to do equals to. Serif. This and this is the progress. this of course is scpalref. And again, I want a tolerance, so I'll just choose a tolerance, and maybe if that's causing problems, I can change it. If it's greater than a tolerance. Alright, so the progress is, because of course we're assuming between 0 and 1. Is a return value. This goes down to 0. Okay, like the value starts at this and goes down, right? Yeah, that should work with floating point numbers. That just doesn't work with yeah, the other method only worked for how do I say? Oh, you know what? Actually, let me go check those other ones to make sure they work, because now that I think about it, if there's any equal signs for these, they might not work with them. Here, let's think about it a little bit. I might have left that in a few times. Yellow here. Okay, but yeah, these ones are all doing less than, so yeah, we're fine. Yeah, I guess I left a few things in. So no, these calculations should be fun. Oh, I didn't leave it in here. Okay, so I guess that was just a bug I threw in later. Not a bug, but I mean, just starts with double precision and then gets converted to float. Yeah, like here. What's going on? Okay, so here, of course, we're gonna change this in a second. So, ooh, wow, okay. Yes, I need 2 tolerances here, actually. Yeah, we have like a bunch of compounding ternaries for some reason. Like at this point, just do an if statement. This is too much. Right, like, yeah, this is going overboard. Okay, if it's equal to 0, okay, so we're gonna do. Wait, I thought okay. Oh, wait, did I control X? But I copied it, right? I'll say low tolerance and I'll say high tolerance. I'll say if X is less than a low tolerance and it's equal to 1, which is just going to mean is greater than a. It's because again we're really just worrying about. Wait, what? Oh yeah, and then these aren't things anymore, so this is progress. Okay, let me switch all these numbers out to floats. This is progress. And then this is the how also this is progress. And then this is a SD power. Okay, next. If key tolerance this. Yeah, I'm gonna write this myself. Let's do if. Current value. Current value is equal to 0.0. Elif and then return 1, and then else if. I think it's just else. Just the remainder of this. Value is equal to this. If then we return this bit. Return value is equal to this bit. And then else. Return value is equal to this, which was this last bit, right? Okay, there we go. And return value. Okay. Yeah, I know this turns into like a way bigger function, but this is way more readable to me. Like, if the progress is less than k, low tolerance, return this. If it's greater than this, minimum. It means the same thing. So ease in expo, right? Not too bad. Oh yeah, so that one took a while. So let's go into the next one. Hopefully it's not so bad. So expo. Yeah. All right. Wait, have I been in, out? Have I been doing that over and over again? Hold on. I just put an error there so I know where to go back to. Yeah, I've been forgetting to put in out everywhere here. Once in. Okay, there we go. Alright, this is where I left off. Alright, so expo to circ. Alright, let's head over into this thing. Expo starts here, looks like. Okay, so expo to circ. And the first circ function is this one. Okay, so std left. std power. Oh, F. Okay. And this is this. Okay. Easy. Okay, yeah. Circ's not too bad. Wait. I think I messed something up. Hold up. Yeah, it's supposed to be a square root. What am I doing? Let's see, square roots. The left. And then progress. There we go. Almost broke that one. Okay. Surprised I'm not seeing any pies anywhere for circle. Okay. So let's do this really quick. F. And this one's going to be std square root F. std F. Am I gonna be doing launches in this one? Doesn't look like it. It's a complicated function though. F. A lot of inversions going on. But I won't try to like pull this one out. This one's fine the way it is. But this person loves ternaries. Okay, so square root, isn't the square root? Right here. std square root stuff. Yep, and then the power. std power, okay. This x value is just progress. And then this x value is just progress, so there's another one. Progress. Okay. Nice. Oh. Circ. Okay, so circ. So back, elastic, and bounce in. I have a feeling these are going to be complicated. Let's see though. Okay, but 3 more. Almost done. We get in there. Kind of nice though, I can kind of turn off my brain a little bit. Sure. To back. What back means. But yeah, should be good. Let's go up to the top of circ. Bring this down. He's in circ. There we go. So find circ, replace with back. Alright, and then let's go check out this function. Oh. Okay, so const export. Oops. I guess I'll leave the C1, sure, why not? And then call export. Oops, C3 is hopefully this is valid. I'll just do this just in case. Okay, we'll see one. I think the thing about const expert is it just checks if everything here is const expert, which this is, so should be fine. Oh yeah, and this is float. Okay, not too bad. Ease out back and everything. This is the floats. This is again const expert. Expert floats. Okay. Like having it in my style. Okay, let's take all these numbers, make sure they're floats. All right. And more x's is progress. And then these two are just power, so the power. Let me see, is std power f good? Yeah, I'll look into the performance. I'm kind of looking into some performance right now, but performance stuff right now, but okay, I'll worry more about that when it becomes a problem. So this is fine. So this floats. Okay, let's get back to in and out. Yeah, wow, that's a function, isn't it? This one has some different numbers too. Looks like I can just find X and replace with progress. Okay, we're good. Look at that. Everywhere we say power, which is these two. Okay. E power. Okay, and then okay. Yeah, that's good. Nice. How's it going? It's looking good. There we go. Hold on. All right, two more. And I have a feeling these are going to be complicated as hell. Inelastic. Oof. Okay. Yeah, we're gonna have to do some tolerance stuff here too. It's kind of annoying. Kind of debating if we even want to do these, but I guess for completeness, I might as well. These two look like they're going to be a lot of headache. Okay, almost done. Let's see. Back to elastic. Elastic. Okay. Was it? Yeah. Okay. So, oh yeah. Okay, there we go. So inelastic is gonna be this one, which is gonna be fun. Okay. So expr float is gonna be this. And this, and this. Let's upgrade actual floats. And then this one, I haven't seen this one in a while. Let me go find it. Yeah, this one. Okay. There we go. So look for all the X's. Yeah, I think all the X's are just X, so X to progress. Let's see, and then get rid of this, get rid of this. And let's just change this really quick. std, wait, was it power? Yeah, std power. And then std sign. Let's find std sign as well. Place of sign F. It's really the only place. Really? What about cosine? It's not using cosine. I mean, I get why, but it's the opposite of sine, so if they're doing it out, you're gonna do the inverse or whatever. I don't know what cosine's inverse of sine. I don't remember the trig identity stuff, but yeah, I'll make sure we do the float version of these. Okay, here we go. So we're in the elastic, so if progress is equal to 0, is equal to 1, and then powf. So let's go find tolerance. I tolerant. Grab these. Okay. So if progress is less than a low tolerance, or if progress is greater than k high tolerance, the rest of these, let's go ahead and swap them out. That's 0f. Or this one just needs an F. C4. Oh yeah. That is 0f. 0f. So no confusion about what's going on. Okay. All right. Okay, I think we're good there. So these will cost X per themselves, and then yeah, just do this calculation. We're good. Elastic. We're doing the out variant, so yep. So C4, let's see if these are the same thing. So C4 is 2.0 times the float divided by 3. Okay, that looks the same. Okay, and then again, we're going to find X with progress. Okay, and then if it's less than a low tolerance, then we'll do that. Let's just move on. And then if it's greater than a high tolerance, again, we can't check. Both floats can't check the exact values, of course. That's not how that works. Okay, so then SD. SD sign F. Wait, this was sign. Yeah. Okay, and then last thing is we're gonna go through here, make sure to convert everything properly. F. This one is just gonna be an F. Okay, and I think we're good there. Let's head back out. And we'll check this last one. He's in out. Oh my gosh. That's the difference in value as well. X for floats. Put this entire thing inside of here. This is just F. This is OF. And then, of course, course, this one is this bit. Okay, and then of course we want our high and low tolerances here. Okay, and then if it's less than the low tolerance, K low, then we'll do that. And if it's greater than high, K high tolerance, there we go. Okay, just replace X with progress. Alright, and then let's just go ahead and change out all these really quick. Okay, and then these two change the power, so this is power, std power, and this is sine, so sine f. Okay, and then the remainder of these ones is f. Let's just change all these. F. Okay, I think we're good. Hopefully this evaluates the same. I don't see why it wouldn't. So, should be fine. Okay, last one, finally. Jeez. Wait, let's go back. So this one is the bounce now. Okay. It still works. Yeah. So that works. Cool. All right, let's go check this out. We're gonna, and this is the last one finally. Ooh, I'm kind of tired of this. We made it. Okay. So elastic out, elastic in. There we go. Find elastic, change to bounce. All right, let's go ahead and transition each one. Oh, nice. It's okay. Okay, well that's cool. All right. This is actually fairly simple. So progress. Of course, this is dot 0f. Dot 0f. And this is going to be ease. Yep, ease in, ticks in, ease out. Okay. Ease out. Bounce. I guess he got lazy. Okay, well, sure. I mean, I would too, to be honest. Okay, maybe I should make these actual functions. Yeah. Okay, we'll just do calc, and then this will be a special case. This isn't defined anywhere. Wait, what? What do you mean this is defined? Yeah, it's down here, right? Which means... Wait, am I missing something? What? Okay, yeah, it's okay, this is referencing this one, which is below it, which means it wouldn't be visible. Okay, I thought I was going crazy. I was like, is there something defined above or something? Have I been making a mistake this entire time? That made me question myself. Okay, so maybe maybe. We should have a private section. And then I'm going to take all of these functions and put them together. I keep doing this. Like a no way of like changing all these really quick as well at the same time. I'm also doing it. I'm also doing it just in case I want to make some more functions later on, and I want to start like mix and matching them. That'd be kind of fun. So I want to have them all available together so that I can do some weird stuff. Good so far, I don't see any issues. Yep, everything is looking good. Good. You know what? Let's put this back. You know what I'm gonna do? Because I kind of actually like having these little files like here. I'm gonna get rid of this private section. Fine, it's fine. I was kind of convincing myself like, oh, this is gonna be good. Let's just swap these. These out. Yeah, we'll just swap these. Fine. And then we'll call this ease out bounce calc. I don't know why I just didn't do the ease in first and then do, I don't know. Yep, ease out bounce calc looks like it's gonna be working. Yeah, I might even just put the ease in first and then the ease out. And then this will just be like this. Okay, now let's do the ease out, which I'm sure is going to be insane. Yep. That is a lot. But at least for this one, he didn't do the giant ternary thing. Because, yeah, these ternaries are killing me. Okay. And then here, expr floats. Right, and then let's go through here. We're gonna find progress. Oh no, X. Progress. progress. Okay. Okay, and then this, and then F. Everyone gets Fs. Alright, let's make this more to my style too. Okay, there we go. Yeah, we have multiple return statements. Interesting. Okay, that looks good. And the ease in is just 1 minus. Okay, let's go check the other one. And we're on the final one. Nice. What? Okay, well, yeah, I mean, I guess that's supposed to. I mean, that makes sense, yeah. Okay, let me go ahead and paste it. I'll show you what I mean. We're just calling this ease. And then this is. Okay, and then let's find next, replace with progress, of course. And then this F, and then the rest of these I'm just gonna... Oh, shoot, no. Oh, these are all ease out, but then the ease in one, I guess he decided to just do it directly in here instead of calling like 3 functions. Sure, yeah, cool. Okay, all right. So that's a lot of easing functions I just added. Oh, my back. Okay. Cool. Nice. All right. Next thing is I want to add an enum. Where it is above. We're going to call it enum. Interpolation type. Okay, and then we're going to go ahead and do a split on this. Where's the split? There it is. How is that having a null type? Okay, linear. Alright, let's go then. So linear ease in sign. Ease out sign. And ease in out sign. Okay, good. Yeah, those are all 3 different curves. The rest of this is just going to be copying and pasting. So, find sign, replace with okay. So sign, replace with cubic. Okay. Find sign. Replace with quartz. Okay. Okay, find sign, replace with quints. Alright, find sign, replace with expo. Sign, replace with circ. Find sign, replace with back. Okay. Okay, then find sign, replace with elastic. Oh, yeah. elastic. Okay, find sign, replace with bounce. Right. And then let's go ahead and remove split. Also, maybe linear. I suppose so. Linear is pretty simple. There's no ease in, ease out variance. Let's do this really quick. I guess my music stopped. Let's see. Let me reload my thing real quick because my music's messed up. Okay. All the way to the bottom. Let's check this out. Quartz. Okay, let's go to Quint. I should just had this like this in the first place. I don't have to do this, but yeah. Insight is yes. Okay. All right, so ease out quad, cubic, quartz, quint, expo, circ, back, elastic, bounce. Okay, and then now we have C++ variations of all these, so that's good. All right, let's go ahead and commit because that was a. Okay, wait. Let's also do one thing really quick. What's the error? I see like an error for some reason. It says up here. What is this? Can be made a static function. Are these all not static? Oh yeah. All right, sure. I should roll this. Let's replace inline. Let's see wherever we use inline. I'm assuming that just means we replace with static. Yeah, whatever. We got a good point. Okay, where is this error though? Okay, I don't know. I think the linter is just messing with me. Okay. All right. Well, let's provide some functions for this now. So we'll copy this over. You know what? Let's ask ChatGPT to do it since the AI is usually pretty good at doing this type of thing. We'll close this as well. Hey, can you give me two functions that converts this enum into a string and vice versa? Oh, I guess gotta reload ChatGPT. Okay. Space and C++. Okay, yeah, there we go. All right, and then I'll add my own little things for this. Gotta include string. That's a good point. Let's include. All right, so now we're gonna do namespace Cardano utility and paste this one in. So we're gonna do inline, right? Return a string. And yeah, I think that's valid. Yeah. Okay, it doesn't know what this is, so we'll do math. There we go. And then for all these, we're going to do math interpolation type. And what's wrong with this one? What do you mean? Oh. There was the error. Hilarious. Quad, cubic, quartz, quints, expo, circ, back, elastic, bounce. Okay. Yeah, I'm cool with that. Yep, and this returns a string. That's fine. Maybe at some point I'll switch this over to like fixed strings and string views. That's just gonna be like a big run through the engine, change that type of thing. Okay, and then of course gotta make it my style. Okay, and then here we're gonna do AG error. Unknown interpolation type provided. Or let's do a critical. Maybe it shouldn't be an error, but it should just be like a. It should just be a warn then. Because I'm thinking you could mess with the values inside of a. You wouldn't want it to crash, right? In that case. The more I think about it, yeah, this is fine. Although I do like being very clear with that, so let's do that. That's good. All right, and then what was the other variant of this? SD exception. Yeah, I'm not doing that. The rest of it's not bad. Let's try this. Okay, so in this case, we're gonna provide a const car pointer. And you know what? Let's start doing this from now on. Of course, this is the math. Right. And then. Okay, I think I can do this. Hold on, I can do this. And then. Because it's all the same spacing. But yeah, it's good for me, honestly. Then we're going to do. Math. Interpolation type. And then of course this one's broken. The SD invalid argument, it's kind of cool. Don't throw anything, please. AG1. What would I do here? Oh, we don't have a base here. Rhino core base. There we go. What's going on? It may fail. Why? Oh, do we need to include log, really? Core log edits, I guess. Wait, doesn't base include log though? It does. What are we talking about? What? Okay, fine. I don't know what's going on here. Yeah, what's up with this? Name followed by must be a class or namespace. Wait, is it because we're... Wait, what? Why is only particles available? Wait, why is particles here in the first place? No, this is broken. Yeah, this is broken. Hold on. What was the comment? It was this. Okay, I'm just gonna leave that. That's fine. We'll return name. And then KG1. And then this one we're going to return math InterpolationType none. Okay. Okay, let's just try to run it. Let's see if the thing's just messing with me. At some point, I'll add maybe like a using function editor, a little graph editor. That might be good. But for now, I mean, these should suffice for like majority of things I need to do. What? Wait, why does it have a break right here? Ease in out expo. Did I mess something up? Is it because of the enum? Maybe. Maybe. I don't know. Let's do an F0 here. There is kind of a collision in the. Oh wait. That should be enum class, my bad. That could be the issue. Oh yeah, okay, yeah, because the enum kind of falls in the same spacing. What is going on here? Where? Did I break something? Wait, what? So confused. Whoa. Okay. Interpolation is not a class or namespace. What do you mean it's not? Wait. Maybe it's because the include files are messed up? That could be the issue. One thing I can do is... because I deleted the file earlier and moved it, so maybe that it like was used to it being in one place. So let's close this. Those scripts. Okay, it looks like they changed the engine, so maybe I'll learn something. Okay. Damn it. Bro, what is going on? Oh, wait a second. Is there a bunch of errors now because I F0'd this? No, it's not F0'd. Huh? Okay, let's just not return it blank, I guess. Try that. Maybe it does just corrupts the file or something? No. What is going on? Interpolation is not a class or namespace. I would beg to differ. We're in the math namespace. Interpolation. Wait, what's wrong? I don't get it. Do I have like a circular include going on somewhere? Or let's remove this for a second. That doesn't make any sense. Okay, wait, let's try and clean solution. Let's build it. Because I don't know why that would be broken. That's so weird. compiling the random files first, I guess. Yeah, what's up with this? It's weird. Turn on this backlight really quick too. Let's see. While this is compiling, hopefully it figures its stuff out. I don't know. Desktop input? Why is it stuck on there? What? Is there like an error going on or something? What? Desktop input. What is it, because it includes math? It doesn't know how to deal with this math thing here? Oh. Oh, okay, I was... okay, that was just me. Alright, okay, wait. It's saying interpolation doesn't exist, which means maybe the class definition is messed up? Which means there's an error somewhere, probably. Oh, wait a second. Hold on. Wait, what? Okay, this closes this. Cargano utility is this one. And then we have inline, and this function starts here. Switch ends and then returns there, yeah. And then this one starts here. And ends here, and then goes here. What's up with this? What do you mean expected to... Huh? Okay, what if I just get rid of this entirely? Just for a second. Hash if0. Hash end if. Let's try that. Oh, there's still an error, huh? Wait a minute. Is this enum messed up? Interpolation type. Something must have not been closed or something. What? Ease in back. Wait, am I not returning anything for any of the... Okay, well that's funny. Oh, I'm really not. Okay, so for all this, let's find linear. And then do starts. Right, is that just these? Okay, and then we're gonna replace it with return space linear art. Okay, let's try that. Oh, Hey, okay. Alright, I was just having some trouble. That's fine. Alright, let's bring back some of these types now. So let's bring back this. And let's see how everything does. Enum, one or more. Oh, is it because I didn't put inline here? Yeah. Yeah, the only two places that use interpolation is CPP, Interpolation.cpp, and the particle service. So that's good. That keeps that minimal. All right, there we go. Okay, nice. We have some easing curves now. I mean, we're not using them right now, but we do have them. Yeah, I kind of like these particles. Okay, let me push the code really quick. And then I'm gonna use the restroom, take a quick break, and then I'll come back, and then I don't know, I guess I'll see where we're gonna continue from there. So add interpolation.h files, which provides basic linear interpolation functions. Provides basic interpolation functions. Basic interpolation functions, yep. Functions for use around the engine. Yeah, just if I need an interpolation function, I can use one of those. And I'll use that enum soon for the types. Remove linear interpolation from the math.cpp/h. Particle service. Not even worth mentioning. Yeah, these aren't even worth mentioning, honestly. Add interpolation curves to the math library. Alright, let's go ahead and commit that. And I'll be back. I'm gonna take a quick break. Alright. Okay, I am back. Alright, so let's go check my little progress board, or my little the workspace where I had all my things I was going to do. So add easing functions, I kind of skipped forward and did this real quick. I kind of went crazy. Not really though. Alright, I want to use the easing functions now though. In the how do I say? In the particle system. So let's try it out. How do we know it's a null pointer? I just checked if it's okay. I don't know. All right, on render. So here's the linear interpolation, right? So I want to be able to use like whatever curve I want, right? So what I'm going to do, right, is go back here. Okay, actually, let's go to... Where is it? Math, interpolation. So I can call any of these curves whenever I want, right? I want to add another section. Okay, I guess I'll put it at the bottom. I don't know. I'm good to place steady. Let's see. All interpolation type. All based on interpolation type. Right. So basically it's gonna do something like this. But it's not gonna be inline, it's gonna be okay, so two things. Static. It's gonna be a void, right? Because it's just gonna call the function, right? What do I call this function? Let me think. I think I hear a cat yelling to come into. Lovely. You okay, kitty? Oh my. Okay, not bad. Not good. Now to you too. Now to you too. All right. All interpolation function. And then what we're going to do is just okay, let's take this out for a second. So this goes down from here to here, right? Actually, yeah, hold on. We'll come back to that. Let's do this, and then we're gonna do this. Call interpolation function. All right, so we're gonna do. All right, so this is gonna be this. Okay. Okay, so all these, right? This is going to be 4, 4, vec 3, vec 3. All right, let's go ahead and put these into the implementation file. All right. Alright, for now I'm gonna do a simple switch for this, just to make it work in general, and then I might make it more performant, particularly for the particles. I might add some more stuff, but just as a general thing, it might be nice to have this ability. So here, right? Basically, we're just going to call I guess return, right? Oh, yeah. So these need to return the appropriate type, right? So there's going to be... we need to get something out of it, right? Okay, so this is going to be float. Event 2. Event 3. And 4. There we go. Linear with start points, end points, and progress. Do this for each one, so we ease in quad. Okay, ease out quad. And ease in out. There we go. So I have to do this a ton of times. But once this is done, it's going to be easy just copy and paste job into these. So it should be easier. And I'm thinking I might add one more thing where I might just return a function pointer as well. That might be more performant, actually. Instead of running the switch statement for every particle. Maybe return a function pointer and then just call that for every, and then we already have a function pointer available, so we can just keep calling it over and over again. That might be a good idea as well. But just generally speaking, if I want to call an easing function based on the type provided, then I can easily just call this function and be done with it. It might be a little less performant, but I still think it's gonna be pretty good. All right, so quad. Find quad, replace with. Where's sign? Did we just forget about sign? Apparently. Oh my god, it's AI. Are you kidding me? Cubic. Okay, the AI forgot about sign. It's kind of annoying. Let me go check something really quick. Why did we forget about sign? Okay. I guess I forgot to put this here. Okay, so that was my bad. Okay, so that wasn't the AI, that was just me. Okay. I guess so. Okay, so this is what, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so they're all accounted for. Alright, so let's head down and fix all my mistakes. The first one is here, I forgot to put sign. Quad, let's put sign. Okay, and then here I put quad, but I forgot sign as well. It's kind of silly. Quad, place sign. Okay, there we go. Alright, now let's head back over to this one. Okay, and then let's get sign in here. Find quad, replace with sign. Alright, cool. So now we're gonna do quartz. So cubic. Find cubic. We'll do quartz. Okay. Alright, let's find quartz. Replace quince. Alright, so Quint. Quint place with Expo. Alright, get rid of Expo. Let's do this one. It's fine. Expo replace with Circ. Replace with back. Okay. I got elastic now. Find back. Replace with elastic. Elastic, replace with bounce, I believe. And I believe we're done. Default. And then I'll say KG1. Could not find interpolation type. When attempting to call make interpolation function call. Alright. Okay, so nice thing about this now is since we got the type overloading, we just do this, this, and this, and they all just work. So there we go. Nice. It's easy as that. So this will call the actual function and return the actual value. Yeah, maybe none should be like a valid type, I don't know. Maybe I'll do this. Yeah, sure. Because I like that in functions, but here it's kind of weird. Okay. Okay, last thing. Last thing. And this is going to be based on performance, so I actually do want to get a proper function pointer out of these. Called based on interpolation type, and then we'll say get function interpolation function based on type. So this is basically the same thing, but we're going to be returning function pointers this time. So we're getting rid of all this. And I think this is how I'm going to render the particles. So let's return all this. And then... And let's see. Let's do this, and then we'll go over to, can you give me a C style pointer that matches this function definition? I always forget the how look function pointers look. So yeah, this is the name of the function. Yep, I recall that. How can I return this type of function from a primary function? Okay. Okay, so I guess I'll do it like this, sure. So let's head up to the top and we'll add some type defs real quick. What is, oh yeah, these are just errors. So type def function binary definitions. All right, so is function is floats function, and this is going to be a float. Okay. Is vec2, vec3, and vec4. This one returns a float, of course. Float. Tons of floats. This one does a vec2, vec3, and vec4. For interpolation. Alright, so now these is going to return in is float function. Is vec2 function. And is vec3 function. Is vec4 function. Get function easing function. Okay, what's wrong with this one? Cannot overload functions distinguished by return type alone. Oh, you can't. Okay, so function, oops, get these in function vec2, vec3, vec3. Okay, there we go. And then let's rename, yeah, all these. Call easing function. By type. Yeah, so for all these, yeah. Function Okay, let's define these. And these are roughly going to look the same as well. Okay, nice and easy. Linear. Does it know what I'm talking about when I say that? Like, hopefully it does. Okay, is this gonna have an issue because it's overloaded the function? I hope not. I hope it understands that we want this type. And then for this, we will return null point. And then return to get an int. Get an easing function. What do you mean? Back to? Oh. Yeah. Okay, there we go. Okay, let's see if this compiles. Yeah, a lot of these functions. But there we go. So now we have the types, right? So we have these types, and then we have function pointers for these, right? And then basically you can call these directly if you want to. It's up to you. I don't know. But the other ways you can do it, you can store one of these, right? The teasing function type we're using. And then if you store that, then you can either call it directly, just using the type and then the variables, or you can get the function pointer back and then maybe call it multiple times and then you're using the same pointer so you don't have to keep looking it up every time. But yeah, there's a lot of options, so whichever one makes sense in the moment. Okay, I'm gonna make another commit here. Let's just say add supporting functions in interpolation.cpp/h to use to call an easing function based on the interpolation type enum, or get the appropriate function pointer based on the interpolation type. You know, it's all I did really. Okay, wait. Let's try to run it really quick before I start committing. Because it could be like, what are you doing? Yep, see? It's like, what are you doing? Let's return a value. What do you mean must return a value? There must be an instance where I don't return a value, huh? Okay, which one are you talking about? Oh, here we go. Call easing function. We just do this. It's easy. Yeah, I don't know what else to put as a null value, but not even really a null value, just to leave it as your f. Okay. Alright, let's try it again. I don't know why you would call an easy function that's not on either a double or a float, honestly. So, I don't know. Like an easy function on integers just does not make any sense. Okay, nice. So, right, let's use them. So this should be fun. Let's go to the particle service, right? And then we're going to include interpolation. Math interpolation. Okay, and now in the config, we're going to provide a math interpolation type. I think size interp type. Interpolation type. And then by defaults, normally I would put none, but actually a good default value for this would be interpolation type. Probably linear. Alright, and then let's put this into for the color as well. Alright, so these two are now variables here, so let's go ahead and serialize them, deserialize them, do all the stuff that needs to be done. So this is an asset, so we're going to go over to the assets. Asset service. This one, okay. And then for this one, I'm gonna do the strategy I always use. So I'm gonna change the, not the serialization code, just the serialization code. And let's open this back up really quick. Where is it? Particle service? Yeah, here it is. Okay, let's go back to here. Okay, let's paste this below. All right, right, and then we're gonna do this color interpretation type. All right, and then this is gonna be color interpolation type. Yep. Of course, we can't serialize that, so we're gonna do a utility. We need interpolation. I think we have that. So we're gonna do interpolation type string, and this is why I did the whole to string thing. And it returns a const car pointer, which can be provided or whatever. All right, now let's take this and then we're gonna put it behind here. Let's bring this down so I can see it. Okay, this is just size now. So size, and then yeah, that still works. All right. Okay, and then we're good. So now we have the interpolation type, the size, and everything. So let's go ahead and open this. And then we're going to go ahead and save the asset really quick so that it now has the correct value in there. We'll move on from here. Let's see. So we'll save it, and then we'll go ahead and add the deserialization code really quick as well. Ooh, and now that I have these easing functions available, I can use them everywhere. Actually, I can easily put them into the UI system now. So that's nice. We just need to make sure we manage the state for that somewhere in the UI system, but other than that, we're good. Okay. Okay, that's still working. Good. And I believe if you open this, oh, well, yeah, there's that one I just added is not there. So let's go ahead and save this really quick. Go back. This doesn't check. I gotta do a thing where it checks at some point. Open file and text enter. Okay, here we go. So now it's saying interpolation type linear. There we go. Just go ahead and close this, and let's head over. Let's grab these two and come down. All right, and then for the color one, we're going to duplicate this, and then we're going to say color interpolation type. Let's get the name. Right, and then we're going to grab it as a std string, and then what we're going to do is we're going to do utility string to interpolation type. Let's bring this down. Okay. C string, since that's what we're providing. Which I believe just gets the pointer to the inner data buffer, so that's pretty easy. Okay, that's about it. So we're going to take this down and then bring it over on top of size and just do the same thing. So now it's going to be size interpolation type. Let's get the appropriate name for it. And I think we're good there. Get rid of this. And now we should be able to deserialize it. Good. Let's make sure it deserializes. Don't have any errors or anything. And last thing is just to add the UI for it, and then I am good. Haha. Good, looks like it deserialized correctly. Alright. Alright, now let's go add the UI really quick. So this one's gonna be a bit more complicated since we're gonna be doing a select options, but we'll get it. Oh, and actually, if we're doing a select options, I should probably do something really quick. I gotta go back. Yeah, do something. Where was I? Interpolation.cpp. Go to the header file and go up top. Okay, one other thing I want to do. I'm going to do std array. And this is going to be interpolation type. It's going to be, I don't know, 31. So 32. And then this is going to be inline. And oh, sorry, s underscore all interpolation types. Sometimes I add these really quick. Yeah, so X is number 31, so it means, yeah, there's 32 options in there. Okay, and then all we do is just do this, really. Interpolation type. That's all we do. So do that, okay. That's there we go. And of course we can convert these to strings and everything. And then, okay, just to make sure this is working, we're also going to provide one warning. This list, and it should throw an error. Yeah, good. But if I made this the same thing, like if I made this in, this wouldn't be an issue. Yeah, it's not an issue. Good. Except the error. Oh, well, I gotta do this, right? Is it type? Okay, so I put this in here because I want to be able to easily loop through everything that exists in this enum, right? So I define this here since everything's kind of defined together here, and then I can use it everywhere else in the engine. That makes it kind of easy. I need to remember to edit this though whenever I edit this, but the nice thing is I can just look straight down this header file and just change everything. And I'm usually good at that point. Although maybe it might be a good call to change this. Like maybe take this and move it into the header file so that I can change it as well. Yeah, maybe. Yeah, that might be a good idea. Well, I guess we'll see. Okay, so let's go add this UI now. So we're gonna head over to EmitterConfig, of course, and go to the properties section, and we're gonna add some select options for these. So on top of here, we're gonna do editor UI select option, select color interp. And then we're gonna make one more for the size. Size info spec. And you know what? Let's move some stuff around. I'm gonna start organizing this. Make my life easier. So we'll put this up top, and then we're gonna make this. We're gonna add another one right here for editor. What is it? Select option. No. Header. I think it's panel header. Collapsing header. That's what it is. I'll be right back. All right, I am back. Okay, so wait, what's wrong? Oh, I must have done this. Okay. Well then. Alright, let's go ahead and let it run. Based on enum, or get the appropriate function pointer based on interpolation. Wait, I never committed this? Bruh. Alright. Okay, that can be a cool effect. Okay. So two things I need to do real quick. Yeah, two things I need to do. Ooh, alright. First thing is I need to prevent that error. Okay, well, okay, no. First thing to do right now is to, how do I say? Push this code. Interpolation. Yeah, in a moment I'm going to fix this up. But yeah, EmitterConfig properties. Let's see. Add supporting functions in Java. Yep. Add supporting functions, sure. Start adding editorUI widgets for new values in EmitterConfig and EmitterConfig properties panel.h. And that's about it. I mean, oh yeah, add enum values in EmitterConfig for choosing InterpolationType in particle surface .cpp. Oh, not h, but adds better support for calling what is it, easing / interpolation functions. Okay. Okay, so a few things on my mind. The first thing is I want to deal with that error that just happened. In order to deal with the error, I gotta add some things. The first thing is, let me go to my editorUI. Yeah, it's over here. And I'm gonna add an option for specifying the boundaries of an integer thing or whatever, and then I'll start adding those boundaries soon. So first thing is, I believe that one is a drag float, I think. Was it drag int? Wait, hold on. Oh no, I think it's a drag int actually. So let's go find drag int. Here it is. So EditInteger, that's what it is. EditInteger spec. Okay, so I'm gonna add one more flag to this. I'm gonna say EditInteger define bounds is equal to bits 1. Okay. Doesn't really matter what number it is, it just needs to be a part of the enum. Okay. And then for public, I'm gonna say int32 underscore t bounds array 2. Just a full array, not too bad. And then I think, okay, let's just do a std array. Std array, this is the type, and then we're gonna do 2. Bounds, okay. And then we're gonna say the initial values of this is 0 and 100. Right. I mean, seems fine. And this way we can define bounds. So now let's look at this drag float, the actual function call. And then we do a drag int. And then I think we can specify some flags for this, I think. Oh, wait, comma, comma, comma. Wait, what is this? Drag int, let's see. %d. Oh, okay, so after this we can find flags. 0. Min is 0, max is 100, right? Ungui slider flags. Let me go check ungui slider flags real quick. Ungui slider flags. We'll take a look at this. Always clamp, huh? Okay, let me go get my cat really quick. Let me check on her. Okay, I think I have an idea. I think I know how these work too. So we're gonna go up to the top of this, and then we're gonna say if spec dot flags and edit integer flags, so integer underscore define bounds, right? So we're gonna have an integer array, int 32 underscore t, std array of an int 32 underscore t, bounds. Okay. Okay, so if the bounds are defined, then we're going to say if the bounds are equal to vec end bounds. Okay. Else, we're going to say, well, actually, we'll just find it as 0. And then we'll say if it's like this, then this, and then wherever we have drag int, let's see. So we have the speed, which I guess we specify as 1, and then after that we have the int min, int max. So here we're going to try to put in bounds at 0, and then bounds at 1. And easy as that. Now we can specify bounds if you want to. But yeah, it's only if we actually specify it. So now we can do this for everything, I guess. So let's go back to EditInteger. Do we have EditInteger vec, like a ivec3, ivec4? I guess I don't, huh? Wait. Integer. No, I guess not. Oh yeah, I never had a reason to, I guess. Okay, sure. Alright, let's go to EditFloats. EditFloats. Okay, so EditFloats define bounds equal to bits. We'll find edit vec2, and it's gonna be vec2 3. It's gonna be, I define these individually because they might have like different functionality per type. Which in the case of here, it actually does. So RGBA actually will be 2. It'll be 1. I don't serialize these or anything, so that should be fine. Okay, so define bounds. And then I'll have a global bounds for all 4 of them. If I need to add like per vertex or per float bounds, I'll add that later, but it doesn't seem necessary. So we're gonna do an std array, and then we're gonna do a float array and 2 of them. And we're saying m bounds. Let's see 0, 0 by default, right? Or actually, I mean, could we just pass this along, to be honest? We need to define, you know, again, I mean, I'm already here, I guess, so whatever. Also, are we defining an array here? Maybe I should make sure we are. Okay. Edit vec3. Edit vec3. Oh. Let me copy it this time. Array. std array floats to and bounds. And this time it's going to be 0, 0, f. Wait, are the edit vec3 bounds, are they supposed to be? Let me check something really quick. Oh. Hold on, let's see. So what are the bounds for edit vec3s? Or drag floats? Okay, so I'm guessing inside of here it does some like checking on the vmin, vmax. Pmin. There's no way we're checking exactly if it's compared to 0, right? Okay, well I'm sure MGUI does some like tolerance checking with that, so yeah, okay, so that's fine. So actually, let's just do .0 and then .0f, right? And then maybe let's not do this. Extra work for like no reason. And then let's just put this to .0f and then .0f, right? Edits vec2. So let's not define bounds. And then array, okay, this one's gonna be a float as well. To this. This is gonna be 0.0f and 0.0f. Okay, and then let's go to edit floats. Okay, get rid of this define bounds thing. Oh, also our RGB it is 1 again. Let's do edit integer. Wait, we're no longer doing this. And then this is just going to be 0. I need to check edit float, make sure it's correct. Okay, I didn't put array there, so it has to be array floats 2 underscore bounds. This is 0.0f and 0.0. Okay. Alright, so this way you can just define the bounds however you want. Yeah, let's find m bounds here now. I'm sure I have them all for them. So edit vec3, vec4, integer, floats, vec2, vec3. Something wrong with this one. Wait, why was it? Wait, I don't get the error. This looks fine. Let me just copy and paste it maybe. Exact same thing. It's probably just the linter being weird. Alright, so let's go back to EditInteger. We'll go to the actual function call. Yeah, this is no longer a thing, so let's erase this. And then here, we're just going to do spec.m. Okay. There we go. Yeah, so now let's go to edit vec2. Alright, here are the bounds. So bounds 0. Right, let me make sure this is doing the right thing. Also 1, right? Yep. Oops. wait, what, speed is 0.01. Maybe I should be able to specify that as well. But yeah, let's just keep going. So we're going to go for drag floats. Okay. Okay. This will all be the same. Alright. Looking good, looking good. These aren't jeez. Another one? Okay, the big value. Okay. How does it ever end? Wait, what? Did you edit this? Really? Okay. Okay, cool. Now we're good. Another thing I might want to specify though, let's go back up to EditFloat. Float scroll speed. And then this by default, what is the default value for this? I don't remember. Okay, well, I'll specify it as 0.01. That's not a value. Okay, now let's go to. Well, let's copy this real quick. Okay. Bounds. There we go. So scroll speed will be 0.01. Scroll speed will be 0.01. And scroll speed will be 0.01. There we go. And this one will be, I believe, an integer, so we'll just go with it's 32 toward t, and scroll speed will do what? Okay, and then what's wrong with the remainder of these? This is still an error for some reason. I don't expected a semicolon. What are you talking about? I have no clue. Alright, whatever. Well, let's head down to here, and then we'll find bounds. Instead, we're going to do drag floats. Let's do drag in reverse. So drag integer or ints, and then we're going to do, because there's only one of these, so it's just that roll speed. Okay. Now we're going to do drag floats. Okay, so now we can specify it, which is nice. It's a pretty easy change too. It's kind of important though. Okay, no, we're good. We are good. All right. So, now, what am I thinking? Okay, so now let's go back to what I was working on, and then I guess now on I can start adding bounds to these things. That's good. Yeah, let's go to properties. And then whenever I submit the buffer, I'm gonna add one more thing. Buffer spec dots and bound now is equal to, I'm gonna provide an array. This is gonna be 1 to and 1000, I guess. Let's put a thing in here. We'll put 100,000. Because what is that? Oh, I read the calculator. Okay. What's that? Buffer size spec dot and scroll speed. It was just 1, so I'm gonna leave it alone. Also spawn rate, I might wanna 0 to like maybe 1,000. Cap it to 1,000 for now. Lifetime, don't want to cap to anything. Lifetime. What's lifetime? It's in the float, right? Okay, so we're gonna go from 0 to oh, that was a good catch. I mean, we wouldn't have done anything. It would just been some stuff wouldn't have set. It would have been annoying though. To like, was that malformed? Can't tell. Oh no, I guess that works. Okay, cool. Yeah, that's a bit. 10,000 seconds. That's a bit much, isn't it? Starting size. I guess I'll start putting bounds and everything. I mean, might as well. Size and spec. 0 to like 10,000. Okay, sure. I mean, I guess when I need to make it bigger, I can, but might as well put some arbitrary bounds on it. Actually, maybe like 100k. It's good value for this. You might want a really big article, you never know. No need to restrict yourself, right? And color, and spec. We'll do 0 to 1.0. That's always good. Alright, let's see if these work. Alright, let's try it. See if it's broken. Version from int3 to where? What? Oh, really? Okay. I guess I'll just do the conversion. Sure. Didn't know that would be a float. It's kind of interesting that's a float. Why would that be a float? You're dragging an int. How would you have a speed in float? I guess that was just something Mr. O'Cornet was just like, let it be. wait, hold on, my avatar is looking a little weird. Oh, that's why. How does this look on stream? Oh my. Alright, let's put it back. Oh, I guess that was messed up for some reason. Alright. There we go. Alright. Let's go to the particle emitter. Alright, now let's try to set buffer size to 0. Why does it let me do that? Okay, that's ridiculous. It lets me do that though. Wait, so maybe there's like a way to specify that in the slider options. It just spawns all of them, waits for them to die, and then goes again. Whoa. What is up with that? Oh, it hangs when I do that. Okay. Yeah. So yeah, some of these are broken. Should not let that happen. Let me go back to my... Crap, I have a lot of tabs open, don't I? Close some of these. These are important. Alright. Let's try it again. So yeah, we're allowed to define like out of bounds values for some reason. Even though it prevents you from specifying them. Like I can only drag this over to like 0, right? And max 1, so that's good. But then I can specify -1, and then it just lets it be -1 for some reason. Okay, yeah, let's not let that happen. Maybe there's like a slider thing or something that's gonna let me fix that, or a flag I can provide. Lighter. Flags. Always clamp. When input manually with center text. Oh yeah, I think did I have that? I don't know. Oh, he's just specifying the bin masks himself. Okay. Disable control click or enter a key. Allowing input. Oh, okay. No round format. Okay. Logarithmic. Make the widget logarithmic when otherwise consider using if. Oh, okay, I got you. Clamp. Okay, so I think I want always clamp. So let's try that. Drag it, and then always clamp. Right. Drag floats. I'm pretty sure this applies as well. Alright, let's go through all these. And we'll provide the flag. So we can stop crashing, hopefully, finally. Quite a few of these. We'll go through all of them. Yep, okay, so we're good? Yep, that's good. Alright, let's try it. Let's see. Turning immediate mode framework into a retain mode framework. Isn't that fun? All right. Cool. All right. So no more errors. Good. Cool. So it lets you type it in, but it doesn't let you confirm it. All right. That's fine. Behavior is interesting. Color picker would be nice, huh? Yeah, color picker would be nice. Okay, I'm gonna do a few things. Well, at least I fixed that bug, so that's good. There we go. Alright, let's get this UI stuff done. Let's head back to properties config. Alright, and maybe not the diff version of it. Let's go to the actual file. Can I just open the file, please? Thank you. Okay, so let's head over here. We're gonna do a few things. So editor. So back to what I was doing before I got back doing that collapsing header thing. You know what? Maybe I'll go through all of my drag ints real quick before I do this and fix them up. You know, never mind. I'm probably doing it. I'll just fix it later. Alright. Editor UI. Collapsing header spec and general options spec. All right, and then this is going to be the header color options header spec. And then all the color stuff will be right here. Size, options, header spec. Nice. Alright, so let's go ahead and initialize all these. So init. So the color stuff and the size stuff is cool. Let's put the lifetime stuff up here. And then the color stuff's right here. Okay, cool. So then we're gonna do general dot label general not widget, general emitter options. Okay. Expanded is equal to false. Anything else I should do? Add to selection list. I don't want a selection list. Flags on expand. Provided text. Yeah, I don't need to provide any data. And flags. Okay. And expanded. I don't know, are there any flags for this? Let's see. Underline title. Underline title. Yeah. Yeah, I guess I'll underline it. Or equals editorUI collapse. Yeah, that one. Okay. General options heading. I might split this out into more options as things get more complicated, but this will just be the general section. Alright, let's get one for the color. Which I could just swore I added the maybe I exited in this options, whatever. Okay, let's find general and swap with color. Okay, yeah. And then size. Color. Size, okay. Article color options, article size options, and this one's more like just general options. Okay, and then I'm gonna add two more really quickly. So start color, end color, and insert spec. So this one's gonna be label. Oh yeah, I forgot. So also for all of these I need to add additional flag. So dot place or equals editorUI lifetime spec. What is this? What type is this? Floats. Floats. Edit floats. Indexed. That's what I wanted. Is it buffer size? I think it's an EditInteger. Here. Okay. Spawn rates. Integer. this one. Spec 4 indented. Okay. Okay, let's do this. Actually, just do this and then flags or equals, and this is a vec3 editorUI. It's vec3 flags indented. All right, there we go. Also, did I set the spawn rate to 1,000? Good. Okay, so they're all indented now, which is good. Okay, real quick. Let's just fix this up so it all renders correctly. So, EmitterConfig, so sizes, blah, 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 yep. Lifetime does go up here. So, editorUI, collapsing header, no. editorUI service, collapsing header. Okay, then we're going to do general. Okay, then we do if general options spec dot is expanded Boolean, so I can take all these and put them in here. All right, and then we're essentially just going to do the same thing, but this is now going to be general. This is going to be color. Okay, then let's take the color options and put them in the color section. And then, okay, it's gonna be size. Okay, take the size options and put them in the size section. Okay. There we go. So now they should get rendered in the wrong little section or whatever. And now let's start adding these select option things for the what is it called, the ramping easy functions. There we go. Okay, so we'll put these at the bottom for this. Yeah, widget, so modify the emitters size interpolation function. Okay. M size interp. What is it? M label is equal to size curve. It's curved. Okay. Size curve, yep. Having underscore flags, we'll definitely want to or equals editorUI. Select option. Pop-up only, handle edit button externally. Oh, I think we do actually want to do that one. Oh wait, do we? No, we don't. That's only for scripts. They just indent it. All right, what else? All right, line counts, I'm not worried about that. M label. Well, line counts, I guess I can go with like 3 for this one. On edit, M on edit, on pop-up. On edit. Actually, let me look at this spec really quick. And on edit. If handle edit button externally is true, and then flags can go here. I'll section it out a bit more. There we go. So this can kind of be the section of I don't know. What would this be? Like options that are only applicable in certain scenarios. So M pop-up action, M pop-up confirm. Just swap these, I don't know. Current option, line count, flags. Yeah, these are just the normal ones. Alright, so I think after this, yeah. Okay, so pop-up action, right, is equal to kg bind class function. Okay, and then confirm action. Confirm action. There we go. And it's gonna do some other stuff. Let me go find an example where I do this. Preferably, a good example would probably be. Oh, actually, I know where a good example is. What is it called? Project panel. Or just do project panel. Close this. Alright, initialize static resources. Somewhere in here there's a good one. I think it's resolution. Here it is. Where's the confirm action? Wait, I just do this externally? Hold on. Yeah, I guess you would, huh? And then you just set it, right? Yeah, it would never really need to change, to be honest, so you could just handle this externally. That's not a bad idea. Okay. Let's comment this out, or let's do like a if 0 and end if. So for, and then this is for the particles, right? So we already have particle. Oh no, we need the interpolation stuff here. So oh no, interpolations is included. Well, just in case, I should include auto inter, just in case. All right, so we're gonna do math s, yeah, all interpolation types, and then we do auto. It's an array, so I can just do whatever this ends up being. I think it's math interpolation type, interpolation type, So for all these types, we're essentially, I'm going to do, I'll call the function this one. Clear options. I mean, assumably it would already be cleared, but I don't know, just for safety, I guess. We're just doing this. Okay, no, so first thing we want is type. Right, and then we're going to convert this to okay, uints _t. Okay, so that can get passed in. The next thing is these are the groups, I guess. So all options. Oh, you know what? Actually, yeah, you know what? Let me try something. I just looked at my time on here. I looked over, it was 2 hours, and I looked back, it's like 5.5 hours. Jeez. I guess so. Okay, let's bring this over here. Okay, well, here we're gonna do something real quick. So let's do this and this, right? And we'll do this, I guess. And I need something listed like this. I'll just do this. So all options, and then do utility enter relation type to string, yep. And then we're going to provide the type that gives the string. Let's do one more. This will be a nice little additional thing we can do. Interpolation type. Oh, well, actually, we'll be doing the other one, so we'll be doing this one. Let's mess that up. Okay. So inline, blah, 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 yeah. Consequent to category. Cat say query. Alright, and then linear, none, but these are still fine. Sign. Okay, so let's get rid of these three. Return sign. There we go. So get rid of this. Get rid of this. Yeah, I like defining all these like types still in here so I can change them in one place. Quadratic. Cubic. I don't even know what quints stands for. Oh, quartz. Quaternic? I'm just making that up, aren't I? Let's see. So, quadratic, cubic, quartic, quintic. Oh, okay. Quartic, okay. Quintic. I didn't know that it went like that. Quintic. And of course it's going to be exponential. Turn. Exponential. Circlic. Circlic. Circlical. Is that a word? Circlical. Is that a word? How to say circle? Circular. What's wrong here? Expected a semicolon. Oh, yeah, you're right. Okay. Yeah, you're right. What is this anyways? Back? I don't even know what that is. Yeah, I'm just gonna go with the back. I mean, I see the curve, but I still don't know what that means, so I don't know. Turn elastic. And then bounce. Okay, there we go. Linear is linear. None is none, right? Default none. Okay. Wait, let's go to all interpolation types. Let's get rid of none. Okay, there we go. All right, so now we can do utility interpolation type to category. All right, easy as that. So we don't need a pop-up action, but a confirm action would be nice. Okay. What does it take? Option entry? Sure. Wait, let's put this back for a second. Okay, I'll leave it alone. Option entry, huh? On modify size code. Option entry. Entry. Okay. And then we should still do roughly this stuff. Actually, let's go back to the full options. Let's go here. Let's put none back. And I'll put 32. Okay, and then let's come down here, and then we'll give the category clear. And we'll say if type is equal to math interpolation type none. We'll just continue. But I realize setting it to none actually doesn't make any sense here. You want it to actually be some type of curve. Like it needs to be some type of curve. So, but I will keep the none type as a thing. Just Okay. So on modify. This doesn't fit. Isn't this a option entry reference? Oh, it needs to be a const reference. Okay. Sure, why not? Okay, the arrow dropped. Good. Oh yeah, this needs to be a const as well. Okay. So we'll say kg asserts that entry dot mhandle is not equal to assets empty handle. That would be weird. And then we're gonna pass size interpolation type is entry dot handle, and then we'll put in what is it, math interpolation type. Oh, I gotta convert it into a uint. Let's bring this down a bit. Okay, we're gonna convert it to its base number type and then just interpolation type. All right, and then we'll set it to modified, and then we're good. Let's see how that looks in the editor. Ooh, okay. Yeah, and then let's set up the color variant of this, and then also just get it hooked up with the actual like rendering aspect of it, and then see if it works. Go from there. All right. Wow, today's been quiet. I guess so, yeah. Okay, looks good. Looks good. Let's try out this. I'd say maybe by default have them expanded. That might be a good idea. Spawn rate per second. Okay. Oh, am I not rendering it? Yeah. Okay, so two things. Make this expanded and then add that thing. So, did I set them to false, really? I just swore I set them to true. Oh, why is it in the false? What? Okay. And the other thing is, let's actually draw this. So let's go to... This was the size one, yeah. So, oh, and this is the kind of tough thing, isn't it? Size interp spec. That's current option. No, interp. Size inter. Current option is equal to, and this is going to be a what? Select option, which is, oh yeah, just one of those, I guess. Okay. Press EmitterConfig window. Enter EmitterConfig. Size interpolation type. Yep. So math interpolation type. I'll say current size interp is equal to this. Okay. And then instead of this, okay, the first thing is the string and the next thing is the value. So we're going to do utility interp type to string and then current size interp. And then here we're just going to do we're going to do uint quantity and then current size interp. Okay, so this just sets it every frame. Not too bad. And then yeah, just do editorUI. Select editorUI service. Select option. And then this one. Okay, let's try it. I did set this to be indented, right? I did. Okay. All right. Choose a charm. What is wrong? Okay. Yeah, there we go. Okay. Linear. Okay. I should specify like a max size for this, huh? Sine, elastic, quartic. Okay, that doesn't do anything, but it's nice though. Let's see if that saves. Yep, using sine. Nice. All right, let's set it up for the color version. So that should be pretty easy, honestly. We just need to essentially do all this. But the color version. This color. Okay, this is the same thing. Okay. Yep, and it's the exact same thing. We're just going to do size and switch it with color. That's it. Nice. We'll do this. All right, and let's go do the drawing function now. So let's go to the draw. And then we'll just draw it, right? So for color, we're going to do find size and do color. Draw option to select color curve. Color interpolation curve. Draw option to select color size interpolation curve. Okay. Size, particle size. Okay. Particle color. And general emitter slash particle options section. Okay, let's check it out. And after this, let's just get these curves actually working and fix any bugs, and we should be good, I think. And after this, I guess I'll set up some scripts for it. But yeah, it's pretty good. Wing tick. Yeah, not bad. I check if the number matches for these things. Okay. Not bad then. Nice. Okay, let's get these curves working and then we'll go and commit. So with all of the setup code that I did and interpolation stuff, this actually should be really easy. So let's go over to particle service. I basically did all the heavy lifting with setting up the pointers and whatnot for this. Now, all I really have to do is just go to, where is it? Wait, why is it none by default actually? Hold on. It's kind of weird. Because none would be undefined. I don't want there to be none as an option. Yeah, why does this load in as none? Wait, what? Wait. He's in out quint. Huh? Wait, yeah, it's weird. Hold on. What am I doing wrong? Okay, wait. Let me make sure these are right. So I'm gonna change this to linear, and I'm gonna change this to linear. Because none really shouldn't be an option. Okay, and then close this because I don't have an automatic checker for that. I should probably add that at some point. Alright, so it's linear now. So let's go ahead and save this. Or this should already be good. So let's close it. Particle emitter. Okay, but like, is it... Okay, it's saying linear for both. Okay, so why is it showing... It's weird. Let me go check. Wait, what? Why is there current 0? Wait, am I not deserializing? Did I forget to deserialize? Hold on. messed that up. Hold on. Where is the emitter manager? I know it's saving, but why is it not? Okay, let's check this really quick. I want this to get called. It's linear, okay. Oh, wait a second. Yeah, okay. I get what's wrong. Okay, so maybe I should put string here for now. Let's see string reference. I mean, it still works. Okay, yeah, because the bounds check, it's probably checking for like a null terminator or something. It's not getting that or something. I don't know. That's the one weird thing about C strings you gotta be careful of. Okay, so I'm gonna go back, and then it doesn't. Let's go put this back. All right, and let me see if I'm doing some C string stuff with this. I think no, it's fine. Okay, let's try to open it up again. So it literally just was not loading it in. Okay, that was the issue. All right, and switch over to some MPs. I gotta wake up. Alright, hopefully that fixed it. Alright, let's take a quick break while it's going. Okay, I guess that was my break. But yeah, so what is it saying now? Okay, linear now. Good. Alright, so it's saying linear now. Good. Okay, what was I gonna do after this? Oh yeah, I was gonna make sure this all works now. Actually doing a linear interpolation. I got proper interpolation. Okay, so yeah, I should probably be able to modify velocities and a bunch of stuff soon. Let's see. So where's the particle manager? All right. So yeah, we're doing math linear. So now what we're gonna do, not gonna be per particles, but per emitter. we're going to get ease. Okay, so what is this for? Ease vector function. We're gonna say size interpolation func. And this one is going to be emitter.config. And then we're going to get the size interpolation type. Right? And then we're going to do utility. Oh, no. This one's actually going to be math. Well, let's bring this down. Okay, so math interpolation. Not call. A lot of functions in here. Gets easing function step 3 on the type. Oh well, just call this, right? And then do this. And there's your statement. Right, and then we're gonna do the same thing, but with the color, which is a vec4 this time. So we're gonna do vec4 is a regular function pointer, which is fairly light. Then we do color func. Size ease func, color ease func. Going to be a vec4, and this is going to be the color interpolation type. All right. So now all we have to do now is just do for the size ease func. There we go. Versus linear, which is going to be color ease func. There we go. So we select it real quick. So get interpolation functions, color / size interpolation functions. Okay. And we get this parameter, so we're not doing every particle, right? Yeah, and then for every particle, we're just going to call this function. Okay. Should be in the cache every time because we're right there. Right? Good. All right, so the only thing left to do is try it out. All right, so we're using linear now, right? All right, so what I'm gonna do is I'm gonna change the starting color. I'm gonna make it white, right? And then we're gonna make the lifetime about, well, the buffer size of 1, so let's change that to 100. Okay, maybe the lifetime can be like 2 seconds, right? Let's make them both 1. The reset button would be nice for this, huh? Oh yeah, and the size, okay, so... Alright, so those are some pretty big ones, right? So they take about 3 seconds, right? Each one spawns, so that's cool. Alright, so now I want to change the color to... Okay, it's going to like this magenta color. Let's do something more distinct. Let's do 0. It's going to yellow. Do like 0.7 on that. let's do 0.5 and then 1. Okay, so it's like this deep greenish kind of color, right? All right, so let's actually, I think color might be a bit difficult to like easily see the curve, right? Let's try like size. We'll go to 0. That's kind of fun. They're kind of like clipping. Okay. You know, yeah, I'll make them like do this. It's kind of easier to see. So let's try. We'll do an ease out. And we'll do a quadratic. Yeah, there we go. Yeah, look, it's easing out, yeah. Because you can see it's kind of slowing down towards the end. Let's try ease in quadratic. Yeah, it kind of speeds up. Am I? You okay, kitty? Alright, let's try ease out and in. Try that. So ease out and in quadratic. Yeah, see, there we go. So it eases out and then eases in. Okay. Okay. It's kind of fun. Okay. There's quite a few things I could do at this point. I mean, I could work on offsets. I could work on spawning them like in a box or in like a cube or a sphere or something like that. I could make them billboard towards me, the camera. Right, it won't be that hard. Just need to do like a rotation. Yeah, I'm trying to actually billboarding it. Would be pretty easy, huh? Because I think all you had to do is just say no to the camera rotation transformation, right? Or am I mistaken? Yeah, it's actually all you have to do. Set up the camera now, I think about it. For billboarding. I'll try quadratic use in and out for and then we'll do like 0. Okay. A little bit of Z fighting though, kind of funny. Yeah, that's probably not good. Yeah, I honestly don't know what to work on next. Kind of choice overload, to be honest. I think maybe a good goal is to actually use the particles in the game. Yeah, because I could probably go crazy with these particles if I wanted to. I think I hear a cat. Let me go get her. Never mind. Yeah, also like a color picker would be nice. Okay. I think two things I'm gonna do. Well, two things. First thing, I'm gonna push the code. Because I got a lot of the UI stuff here done. So that's good. Yeah, let me see. So let's go ahead and push this code, see what we did in each section. Easing function. Okay. Use easing functions. Use provided easing functions. Use easing functions when calculating size color in particle service. That's CP. Okay. modify specifications in editorUI.cpp h to for control of the scroll speed and bounds of EditFloat, EditVec2, EditInteger, etc. It's not worth mentioning, honestly. Widgets. Modify interpolation curves of color by size for emitters. And emitter and now use easing functions for circles. Nice. This is for radio. Okay. Okay, so I think I have two goals I'm gonna do. First one is I want to add an offset. I'm kind of in the go crazy section, so I'll add another in here, but add offset to particle generation. Oh, offset to the emitter. Okay, let's add an offset and get emitter to follow entity. Okay. Yeah, I think those two are fairly important. All right. So let's head over here. Vec3 emitter offset. And of course the default value should be just 0. Right. Okay, I'm adding enum up here. Emitter motion. None is equal to 0. Which actually should be the default value in this case. None is actually a valid value. Enum class emitter motion. Follow entity. Okay. Constant velocity. Well, I'll stop there. That's good enough. These are all pretty easy to implement. I'm wondering if I should put the velocity here or if I should put the velocity in here. This is the position, right? Really, offset's pretty easy. Just update the position and you're good. Actually, yeah, that's literally it. Pretty easy. Okay, I think I'll put it here, I guess. Offsets and velocity. Number 3, emitter velocity. And then of course it would just be 0.0. And we're just gonna keep expanding this as needed. And then when we're here, we're gonna add motion type. So we're gonna add emitter motion type. Motion type. Motion type. I guess let's keep it to motion type. Motion type. None. There we go. All right, there we go. So we got 3 values, and then these will define how the emitter moves around, right? Okay. And then one more thing, we're going to add an ECS entity. Did I already add that? Scene. ECS entity. Did I break something? I don't understand. Is it a struct or wait. Entity. Is it a class? It's a class, okay. Class entity. All right. should I specify a velocity for an emitter? I guess so. All right, and then here we're gonna do ECS entity and parents entity. All right, and we get a pointer, so because it's not defined here, that's fine. I think we're good. Okay. Trying to think. Life cycle. Let's see. All right, let's say the first part of life cycle, it'll be, what is it? What's the word for living forever? Can't think of it for some reason. Immortal. I don't know why I couldn't think of this. Immortal. Fixed time. Okay. And if it is fixed time, we should know how long it has left to live. Floats. End time. Death time. I guess so. Okay, I'll keep it consistent. And also, why is this not m underscore? Yeah, just the confirm ones, yeah. Wait, what? Whoa, 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 whoa. Box 2D, dependencies. Do changes. Whoa, 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 whoa. Okay, that's annoying. I should have looked. I didn't see it. It was in the comments. Undo changes. Okay, I see all inactive. Really? Anyway, I could have swore the only change I just made was, wait, what did I just commit? What's my commit just now? Oh, hey Eliza Legendary, how's it going? I'm just what is it? Working on my particle system right now, but since it's your first time here, I work on a engine, so that's mainly what I'm do on this stream, I guess. Yeah, so yeah, I mean, I'm just coding right now. I just made I don't know, big mistake where I like made all the comments change over. Or how do I say? I did like the what is the word? Sorry if I'm kind of all over the place. I think I've been streaming for it's almost 7 hours, so I'm kind of my brain's kind of but yeah, I like auto change like 46 files in accident. I'm trying to see what I can like keep and what I need to get rid of. Let me check my commits really quick and see. But I guess I can show you the editor as it is right now. I was really gonna change everything because of the comments. Oh my. What are you programming? What are you working on? I get a few people who come by, they're working on like various projects. It's pretty cool though. Oh, you're doing skeletal animations. Yeah. Are you doing skeletal animations? I think the furthest I got with skeletal animations is like just setting up like 3D models on OpenGL, or what is it? Learn OpenGL? Was that one? I never checked out the OpenGL bindings on C# though. That's pretty cool. C# OpenGL. Let me take a look. Yeah, and voxel engine is a lot. I know you gotta set up a lot of what is that, like creating the vertex buffers and index buffers yourself to get it to like draw everything. Yeah, I don't envy that code. OpenTK. Okay. Let me take a look. OpenTK. Never heard of that one. He said it's premium. Oh my. Is fast, low-level C# wrapper. Okay, I have it in my other screen. Let me open it up. Let's see. OpenTK, huh? What's to work on? We will consume contributions. Very fast C# bind to OpenGL. Oh, they give you a binding to OpenAL too. So, what's OpenCL? I feel like I've heard that term, but I don't know what that is. 3D, cross-platform 3D. Okay, well yeah, they're doing OpenGL ES, so that's good. That would be cross-platform. Oh, they're still doing mono with it? That was the thing, I got so tired of dealing with mono, I'm not gonna lie. I was trying to set up C# scripting for this engine. I got it working, but it was, I don't know, dealing with mono was really annoying. Let's see. Oh, see the follow. Thanks for the follow, by the way. As this is my first time. Oh, okay, well, yeah, I don't know what OpenCL is, so, but OpenAL is an audio library. That's what I use for my audio. So yeah, I guess I'll give you like a showcase of the engine. So you can fully create a game in the engine, so you can like create a project and then export it. So that all works and whatnot. I like that to give you Piccolo. Piccolo's sick. So right now I'm working on Pong, you know, just trying to get a game working before I start going crazy with it. We'll go ahead and hopefully I didn't break anything when I was messing with stuff just now. So yeah, this is the editor. Again, just working on Pong, but it's all in 3D. Everything technically can work in 3D. What is this one? Like if I go here and go to the mesh for this one, I don't know what's being shaped, but I can change this to cube. Hopefully it doesn't crash. Remember, it crashes sometimes. But everything does, there are 3D meshes for these things, but currently the game is 2D. Yeah. But yeah, all the editors in like ImGUI. Let me see, what other features should I mention? Oh yeah, so there's an ECS system. I think it's pretty typical nowadays, kind of similar to like Unity, I guess. Yeah, I appreciate it. Yeah, there's a lot of effort for the what is it, the editor. So trying to think what else I should say. Oh yeah, I have my own scripting system. So I wrote my own scripting language and my own compiler for it. Probably should have used LLVM, honestly, but yeah, you live and learn. But yeah, it has its own linter and everything. You can like write full scripts, and in these scripts they compile into C++, which then further can be compiled into like its own DLL, and then that hot reloads into the engine, so you can like hot reload scripts directly in the engine. You said how come? Yeah, no, I wrote my own like UI code on top of ImGUI. So I did a lot of like the spacing and stuff myself, and I kind of turned ImGUI from like a immediate mode being like you write everything like directly yourself as like function calls, to like it's kind of a retained mode UI now. So there's like widgets you instantiate, and then you set the values, and then like you interact with it type of deal. But yeah, so that's how all this is rendering, but it's still ImGUI though. I don't think what else I should show you right now. So recently I've been working on like UI. I made this like UI editor, so hopefully it doesn't crash while I'm showing. Don't show anything. But yeah, you can modify UI here. It has like widgets and whatnot. So I was in the middle of doing this. I spent like 15 streams working on this, and I got really tired of dealing with like text. It's kind of pissing me off, I'm not gonna lie. So I took a break, and I've been working on particles. So I've been working on this particle emitter, and this is what I'm doing right now. So right now I'm just messing with this thing. You can do kind of like basic particle stuff, so you can like, I don't know how much size one, I'm change to like 1,000, and then change the spawn rate to like 10, There we go. So it spawns like a million things. And I just added like easing curves. Like I spent the whole day today just adding easing curves. So now you can do like easing functions for like the color and the size. And oh man, this thing's going crazy. Oh. AST nodes. I have not heard of that before. But I will look it up though. AST nodes. We talking about like an abstract syntax tree? Like a compiler? The UI, I mean, I can kind of show you how that UI is like rendered though. Oh, for sure. Yeah, I've never looked into it. So, like Hikey, when I wrote my compiler, I just kind of was like, I mean, I use an abstract syntax tree for the compiler, but if you look at my compiler code, it's kind of it's a mess. The tokenizer, the what is it? Like I don't even have like separate layers for different things. Like it's just the tokenizer, the parser, and the generator. And I know I could separate the parser into more things, but it's kind of like a big jumble right now. I'm kind of scared to show anyone that. Let's see. But I mean, yeah, the UI code's fairly simple. I can kind of like show you an example. This thing's bothering me so much, this comment thing. Or this, I messed up so much stuff just now. I gotta fix that. What's a good example I can show you? I want to show you a nice one too, not like a garbage one I wrote. Let's do the UI editor. Let's do the properties panel. That was pretty good. So, like my widgets, I have them defined like if the linter will load. They're their own like little like stack allocated objects, right? And then they're just specs, right? So each spec has a bunch of like options and whatnot. And then when you render this, it's like here's all the MGUI code. So this is the actual render code for it, and the specs just choose like the spec just determines like how it actually gets rendered. Yeah. But yeah, I mean, basically you initialize a spec and then you draw the spec. That's all you do, and then you just have a bunch of options for it. That's kind of the long and short of it. And that's why it's retain mode, because all of like the data is retained in the spec. Right. And then of course MGUI, I don't know if you're familiar like writing MGUI code, but this is like basic MGUI code. Pushing, popping fonts and what is it? Hey, wait, what am I doing here? Collapsing header? I guess I'm just drawing text here. And just some like Boolean options and whatnot. But yeah, I mean, that's pretty much, just know that, wait, I don't know much about compilers. I just happen to know that they also use this often in compiler backends. Oh, okay, I got you, yeah. Yeah, like I know of the abstract syntax tree, but I have never seen it used somewhere else. So that's new to me. That's cool though. Yeah, I mean, if you have any questions or anything, just let me know. But yeah, again, right now I'm just working on like the particle system, and right now I just kind of blundered and broke this thing. So I think the only changes I made since the last commit was this. So maybe I can revert everything other than this. Let's see. I'll kind of explain better what I'm doing after I fix this, but such a mess. Thing is, I don't want to accidentally undo something that I already just worked on. Let me see. physics, projects, rendering, runtime, scenes, scripting, and the runtime app. I didn't change any of this recently, so let's undo this. And it's still there. Yeah, I'm trying to think. Yeah, I've never done a voxel engine though. I mean, I'm assuming, like, from my understanding is you would, I mean, you do the chunks, right? Like you would get, you have a square, like a cube. And then you have a chunk, which would be a bunch of cubes, right? But then when you're rendering, you wouldn't want to render every single vertex if it's not being seen. So you kind of write your own like occlusion code, assuming. So like you don't render the inner cubes, right? Make it like one big vertex. Or one big box, I guess. And then of course you need to like go further out, right? So then you have to like spawn in chunks and spawn out chunks, right? So you gotta manage that as like its own system. Oh, okay, so you just do straight culling and then just call it a day. Oh, that's fair. Oh. Yeah, I think I watched a video of someone like talking about that, and I mean, I understand like the graphics part of it, but also like putting it together kind of confuses me. Okay, viewports. I wish I knew what I just changed. I wonder if I can look back at my current VOD and see what I changed. Just give me a moment. I'm gonna go on Twitch. Oh, also, if I talk a lot, I talk in general because I post all of my VODs on YouTube. So don't feel compelled to respond if I'm just talking. By the way. Let's see. This one. Okay, let me go. I'm just looking at my channel really quick. I mean, look at me, right? Like we're both kind of in the same boat with that one. just using like a big scope project. But low-key, that's where like the most fun is. I'm not gonna lie. Just over-scoping it. Wait, can I play back this? I'm looking at my own like Twitch thing right now. I'm trying to see if I can look back at the video. I guess I can't while it's viewing. Damn. Right. You know what I'm saying, right? Like, it's really nice when people come in and like, I mean, I already have the editor. There's still a lot of like, of course, there's a million features I want to add to the engine. Right, it's nothing in comparison to like some of the things I've seen recently of people making engines by themselves. Like people go crazy. I don't know. I mean, I wish I could be that crazy. I aspire to that. But I mean, I think my editor UI looks pretty good. And I think when people come in, they're like, "Oh, okay, like you're like fairly far along." It seems with it, because I think when people just start like working on a project or whatever, they start working on like a graphics project, and then like if you're streaming and people come in, like people are gonna like, I don't know if I want to cuss, but like they're gonna like shit on you. I'm not gonna lie, they're like, "Why are you doing this? Just do the," you know. But when people come in here, they like for the most part, even like the people that are usually negative are still kind of like, "Oh well, like you're actually doing it." I'm like, yeah. Yeah. So yeah, I don't know if my ego could have taken like people talking smack about like my engine when it was small. I think that would have. Oh, wait, hold on. I'm coughing on something. I think that would have hurt me too much. But yeah, I appreciate Appreciate it. Okay, let me see. Okay, I definitely didn't code in the launcher. I definitely didn't code in Windows. Platform. Rendering, API. Okay, yeah, none of this. Maybe this one. I didn't code an AI. Assets, no. Audio, no. Core. Oh, I heard you type, by the way. I'm just gonna try to get this done really quick because I get distracted easy. Let me just make sure. Okay, so the only one I think, yeah, script scene, runtime UI, projects, physics. Okay, so particles is the one I think I made some changes in. And then the editor, let me just check really quick. Main window, user interface, I didn't do any changes. So the only one that I didn't changes is this too. And for this one, yeah, there's really nothing. This one's nothing. Okay, I think it's just this. Okay, there we go. Let's reveal things until they are ready. Yeah, I feel that. I think when I start making like games that I really care about, I will adopt your mindset with that. It's cool doing all this stuff on stream, but you gotta bake some things. I agree. Yeah, I think I was working on this project for like a year and a half before I started streaming, so it gave me a little bit of time. What is this? Current time minus... So I changed these ones, I guess. Oh, I modified those. Okay, you know what? Let me do something. I'm gonna save this file really quick. Because I want to keep these. Yeah, Nercom seems like I'm all over the place right now. Like, I really blundered right before you came in, so I'm just like trying to figure out what to do now. Okay, let's open this. There we go. And then let's take this file. And then we're gonna throw it in my little notepad thing. Alright, there we go. So now I'm gonna revert back. So I'm gonna take everything here. I'm gonna pray I didn't change anything else. I don't think I did. I just committed. Ah, that hurts. Okay. Let me close and reopen. Beginner in general. I mean, probably the advice of keep your project small, right? Like that's the the thing. Like we all should be doing probably, but are not. So, graphics specifically though. I mean, I don't know. Like are you using any like specific resources to learn like graphics? I mean, you're doing OpenTK, right? And you're doing C#, so I'm assuming you're following some stuff in C# in particular. You know what? I do have one bit of advice, I guess. This isn't graphics in general, but I would say if you're making like a really big project or anything just substantial, I would say don't worry about like having things perfect. You can fix them later. I think I fell into that trap a little bit when I first started, like a lot. And then I realized like there's like a certain level of done you can get where it's like it works. And then like as you learn, you like get more skills where you can like how do you say? Where like you will naturally write code that's cleaner, and then you can go back and like do big cleanups. But going back and refactoring over and over and over again is not worth it. You're not gonna do anything. Right, exactly, yeah. And again, if you write bad code right now, I mean, you can always go back and fix it, right? I mean, I do that all the time. Like I go through the engine and then, right, like I'll write a system and then like, if I need to refactor something, like if I'm adding a new feature to an old system, I'll go back and then I'll refactor it when I need to, right? I won't like try to make it perfect the first time and like, oh, like it's all perfect, because I might change my mind later. I might be like, oh, I now know a new way to code. So like all of that effort I put trying to make everything perfect prior is just kind of stupid now, like to my newer knowledge brain, right? So yeah, I mean, I don't know. But yeah, graphics specifically, I don't know, I'm kind of weak on graphics too, to be honest. Yeah. But also, I don't know, maybe you don't take advice from me. I'm just like a random dude. I don't make any money from this. I wish I could. Maybe I should just be making a game with an actual engine instead of making an engine. But here we are. Well, I mean, if you see it that way, then I suppose, but I don't know. There's always so much stuff to learn, you know. Yeah, but yeah, let me see. I'm trying to think. Okay, can I revert to the previous commit? I don't want it to be headless. Okay, you know what I'm doing? I'm gonna delete. Okay, wait, actually, before I do that, let me run this. I'm gonna make sure I didn't make any changes to my actual game. All right, I'm gonna go ahead and push that change, because if I delete, what I'm gonna do is I'm gonna delete my entire thing and re-pull it from GitHub. I'll probably push the current changes too. We're just gonna make a test, which I should stop the test before it messes up my computer. Kind of rambling too. Okay. Okay, one thing at a time. I'll let this compile. I'll push Pong, and then I'll delete the solution and reload it. Import models from graphic design software like 3D Max or Blender. So I used to have I used to have a model importer, but I took it all out because it was overcomplicating my engine at that point. So I'm gonna come back and add it again. Right now I don't really have a good abstraction for putting together a bunch of meshes into like one entity or one like asset. So. But I have done it before, so I could. I'm just waiting for the right time. Or short answer, no. I don't know. At some point, I want to make my own little like animation pipeline, where I can make my own little animations in the editor. It doesn't seem that hard. I mean, I say that and it's gonna be like crazy hard, but I mean, I already know how to load in the models and everything. So the main thing is just getting all the orders right. Inverse kinematics is annoying. You know, I was really scared of setting up like an animation page, but then I was in this guy, his name's AK Elements. I don't know if that's his name. He's really good. He's made like professional games before. he streams, like, I go into stream sometimes. And he showed me this page. Oh, it's actually in my bookmarks. Let me take a look. Well, I mean, I don't know if you use ImGUI, but for me, I was looking for a sequencer, and he showed me this page. I didn't know there was like a whole page of like all of the extensions that Ocornet, like the creator of ImGUI, is like cool with. And there's a few sequencers. I'm not using one of these. And then you can kind of like set up like a basic animation system with this. Were you doing a lot of was it like sprite animations, or were you doing like 3D animations? Both of them sound like hell in their own respect, to be honest now. But yeah, I am hoping setting up with some of these widgets and everything, right? It'll make setting up an animation easier. I already know how to render my own like images and everything, so this was the part that was scaring me. But now that I have this, where I could use this, it's like, no, I could do it, you know? Yeah. Yeah. And that was the one thing too, like, when I make, like, I want to have my own pipeline so I can just use my own tech, right, to make my own games. I mean, that's the whole point of the engine, so I don't have to deal with, like, weird conversion things. I can just make it in the engine. I already know how the code works. Let's make the game, right? Yeah, I don't know if you ever use ImGUI, but they have like a ton of stuff on this page. Text editors. This is the text editor I used. I edited it very heavily though. But yeah, I see they have a fewer new ones. The guy who made this one stopped supporting it, so that's why I had to make a lot of changes to it. Yeah, it's actually part of the main creator of ImGUI, his repo. Like in his wiki. So like I guess he recommends them. I don't know. I think, what is his name? AK Elements. He was using this node editor. I'm not a huge fan of node graphs though, I'm not gonna lie. I like my things being in code, so. But if you're into that kind of thing, like, this is pretty sick. Text editors, that's cool, you know. I mean, you can just use a normal text editor, to be honest. 3D plugin's sick though. I might use this curve editor too. I'm a little stupid on my algebra, so. Oh, hey, Sionix. I say it's your first time chatting. Welcome. Liza Legendary is new here too, so I was talking to them about the engine and whatnot. I was looking at some like ImGUI stuff. I don't know if you did or whatever. It's chill right now. I messed up something in my engine, so I'm trying to reset my engine really quick. But otherwise, thanks for asking. I'm good. Chilling. Yeah, right, like code versus nodes, right, Liza? I feel that. Like, I don't know, well, I'm a coder, so like I'm more used to it. So but yeah, Sionix, this is my engine. By the way, I guess I'll tell you about it too. So what is it? I'll just show you around. So this is the viewport and everything. Has like a typical like ECS system and like Unity. I know they have there's kind of like a flat definition. Godot has a like node system, I think. They go on with that. Oh yeah, what's up, Sionix? Let's see. So yeah, let me go ahead and continue. Well, that compiled now, so let me go ahead and check. What was it? My brain. Okay, so I was going to. Oh yeah, I was going to load the editor to make sure that I can build or I can push palm. There we go. Let's see. Okay, git status. Let's check. So struggle people are telling me to just write codes down, but how am I supposed to write down? I don't know what everything does. Yeah, that's kind of the tough thing when you're starting. Yeah. Yeah, and then the general advice, like, just do it. Like, that's not super helpful. I mean, is there anything, so you're learning how to code, like, is there any projects that you were thinking of that you might work on? When I started coding, my first projects were like a simple, like, console app. It's like, what are those games that, like, you make back in the day? What are they called? Console games. There's a word for it. I can't remember the name. What was the console? Text-based games? Oh yeah, like text-based games. I think I have like an image. Let's see one. Yeah, I think I remember my first like course. It was like in Python, and they had me like make one of these like text-based games. It's really hard to see. Thing. But yeah, I mean, those are just a bunch of if statements, and then like writing text depending on like what the case is. But yeah, like, I mean, whatever you want to work on, right? Like, there's a lot of little projects you can work on. And I started with Java too. I think I did Python, and then they did with Java. Yeah. A simple project, but I don't know what a simple project or a beginner project. Minecraft. Well, yeah, they have. Those are pretty chill. Oh, also, there's another streamer who was working on admin of code. That one's pretty cool. Let me see if I can find his page. What was his name? Discourager of Hesitancy. I go in his stream too and chill with him. It's like a series of like problems they give you, and then like you have to like solve them. But like you kind of like choose how you want to go about it, and it's not like super like, it's pretty chill and lenient, but you get to learn a lot of things with it. Hell yeah. Yeah, I've never written a Minecraft plugin though. How is that, Liza? It's basically just scripting. Let me check my thing real quick. Right. I just remember people making all those shader plugins back in the day, but I know that's like a whole thing. Okay, well, let me see. Let me add this really quick. Add status. Okay, so it's all these particles. Oh, I deleted that one. I added that one. Okay. Git commits -m. I'm trying to think of what to comment for this one really quick. There is wait, no. Small updates to assets to be up to date with people. system changes in engine. Yeah, that's a good commit message for that. I don't really go crazy with commit messages for the Pong, honestly. Maybe I should. Origin main. Okay, there we go. I really do not like Java Minecraft codebase. Yeah, I mean Java codebase the like just straight OOP is kind of wild. I don't hate OOP like entirely, but like it's just like when we make a whole language like force you to use OOP, that's kind of ridiculous. OOP has its places in certain scenarios. I mean, there's a reason why people made it, but yeah, it's not for everything. So I'll just copy what they do and learn my code is writing the code. If that makes sense. That's okay. Copy and improves. Insert your own ideas. Yeah, and if that doesn't work for you, you could do the thing I did to learn program. I wrote a Minecraft server from scratch. First term Java because I copied your work I didn't understand. Then all you're missing is asking for new things. OP exists, but skill issues exist. Yep. That is my opinion on it, and that I use. I think I remember they had me do like a basic like banking system thing in my university. Those are pretty good. I mean, you're just managing the objects and making sure things are atomic, right? Or subatomic. Like you don't have multiple things happening at one time, right? But yeah, if it's just a normal single-threaded application, you just have it do its transactions, and I can see it. Not too bad. I could also see you taking that in like crazy directions though. I mean, most of the work I set up for my engine came from following like a video series on the channel on YouTube. I just got towards the end of the series and then started writing my own code. But I didn't understand any of the code starting off, and then towards the end I was like, okay, I think I can add some things. All right. There's some other, you know what, let me look at some other my other old projects I worked on. I'm gonna take a look. Now I'm curious. I haven't seen those in a while. Personal projects. What was it? Maybe. Oh yeah, I have some Java programs I wrote. They're kind of jank though. Oh yeah, there's the game. I think I had a Python game. Does it work? Let me see. Yeah, there we go. If I can scroll in. So this one, I think, is like 3 files. Right? And I think it's like 500 lines of code for this one. And I mean, this is like super small. Right? And it's like a whole little game. Right. Well, let me see. Collect all weapons to deal with the warlord, and then yeah, I think you just type go east, and then like go north. Oh, actually, isn't it the broken version of this? No. Oh, this is the old version, I think. Bruh. Or what is this other one? I wrote another one in Java, I think. There it is. Yeah. So this is an old, like, this is like an old game that I wrote in Java, and I used like JFrame, I think. And I think I followed a series on like YouTube or something like that. And yeah, I mean, like these, everything here is drawn like on like the CPU. What is it? JFrame? It's just like the Java like window, I guess. Like, you know, like if you're making a window on C#, I think in the backend they probably use like glibw or like SDL. Those libraries they call like the window, like the Windows API calls to open a window. This JFrame is like the Java version of that. So it just opens a window and then it gives you like a canvas, kind of like in HTML. And then you can just draw like things straight on the canvas. Yeah. But yeah, like everything here is written on the CPU. And I'm literally like drawing like each pixel like scan line like this, like directly on. Instead of like, of course, like if you're doing OpenGL, you're doing vertices and then drawing textures, right? No, but I think this one is like, how big is this code base? Let me see. Block. I don't think it's that big. Oh, it refuses to tell me. Okay, never mind. I don't know, but I'm pretty sure it's like 1,000 lines of code in total. That's like the whole program. CPU rendering, I mean, it's super inefficient. I wouldn't do it. But it's, I mean, it's fun. I mean, it's like logically what you would think of if like you were, like if you just had like a giant buffer of data for every pixel, and then you said, okay, I want to draw this guy right here, right? Okay, I'm gonna move my like pointer of of the buffer. I'm gonna move my pointer of the buffer down to here at this location, and I'm gonna draw straight across. And then you're just gonna keep going and going until the image is drawn. And then that's it. Right. And then you do this for the entire like canvas. And you write your own abstractions. Yeah, basically frame buffers. Yeah, but like again, like all the objects are written like frame buffers instead of being written like a normal vertex VBO, vertex fragment shader stuff. So also, I mean like to be honest, like when you're coding like something complicated. Oh, thanks MCH, by the way, I appreciate it. When you're coding something complicated, like I feel like you're getting too locked into like I need to be perfect. Like I feel like just figure out what you want to do and then just like get the minimum things to just do it, and then just like break it into small bits, right? So like say if you were setting up a banking system, right? Okay, well, we need objects for money, right? So you make a struct for money. Okay, you need to make a system, right? So okay, I would make a class for struct for a system, right? And then okay, I want it to do this thing. Like I want to like add money to an account, right? Okay, we make a struct for an account, and then we get what is it? Like a function that like takes a certain number and then adds that number to that particular account, right? And you just go like bit by bit, right? Like you just take each problem and deal with it individually, right? Right, and then like you just learn like as you go, right? And yeah, you don't need to be perfect. You just go through it, and then if the implementation is shoddy, it's shoddy. Go back and fix it, right? And rinse and repeat. Thanks for the follow, by the way. Appreciate it. But yeah, yeah, that's all I can think of for advice for that one. Let's see. Okay, so let me do something really quick. I push this. Let me go ahead and delete some stuff. Oh yeah. I think I see that what's up in the chat. I kind of wanted to show you like the progress I got real quick. So I got these things rendering colors, man. And I got what is it? Let's see. You can actually edit these now. I don't know why this buffer is 1. Let me see. 1000. 10. And then I added like interpolation curves for these. So let me do like 0 and then 0. And then if I do like, I think 3 seconds for the lifetime, they fade out. Yeah, it's coming together. I think I'm gonna finish up with the particle system probably tomorrow, and I'll be back to like working on like UI stuff. So let me go ahead and delete this now. So I'm gonna delete this one. Yeah. Psionics. You know, sometimes I get like kind of like a panic attack. Or not, well, I don't know. But like when I'm like thinking of all the things I can add to my engine, you know what I'm saying? Like I'm thinking like every single option, and I start comparing myself to all the different people who like written their own engines and all the, I mean, of course, you compare yourself to Unity and Godot, and you're like, oh my God, I want this, I want that, I want this, you know? And it's just like overload. But yeah, you can't focus on everything. You gotta just focus on like one thing at a time. And if you need a break, just take a break. Okay, I'm gonna delete this. Let's go ahead and delete that. And then I'll go ahead and wait. Oh no. Did I? Oh no, wait. Alright, can I undo it? I think I put it into my recycle bin. No. Hold on. Okay. Let me think for a second. Recycle bin. Interpolation. Right. Did I just... Okay. I'm talking about at the same time. Let me check my GitHub really quick. Please don't tell me. Yeah, because it's a big file, so if it's too big, it doesn't cache it. Yeah, I knew that, but I was just okay. Let me think. How much progress did I get today? Okay, that's really annoying. Hold on. Did I really? Yeah, it's gone, isn't it? Okay. Let me not do any more memory things. I wonder if I think in my applications I have I think I'll talk to you. Yeah. Oh shoot. Okay. Wait. Are my commits stored anywhere on my computer? Okay. I mean, I guess today, how much work did I get done? I believe I got, oh no, I got a decent amount of work today done actually. Damn. Okay, so I'm trying to think how are my ChatGPT are my commits just deleted a large on my Windows notes in my example, and is there any way to recover it? Because I already committed it, so I just need the .git file. Let me see. Software. Let's see. Install Cuva. Should install it on a different drive from one June. Start deep scan. Okay, I don't think I have any software on my drive that modifies data consistently. Most of it's on the OS. So everything on this file system for this F drive is pretty static. So hopefully there's no data being changed. I gotta figure out if I can recover those commits. If I can't, it is what it is, whatever. I mean, I'll do it again. But dang, I think that what I did for let's see. No, sorry. I know this company. Yeah, I can't. Yep, it's too big. free and paid available. Distro. Okay, I'm gonna look for some options. Do you guys know any data recovery software? Data recovery software. For Windows, let me see. Disk drill Recuva. Disk drill. Okay, so I'm seeing two. Windows file recovery. Let's check on Reddit. If anyone says anything about these. Okay, I might try distro. Let me see how much it costs though. Because the commit sizes I think are fairly small, so maybe I can get them. All right, I guess it's data recovery stream. Oh my. If I didn't have this repository on Git though, this would be a tragedy. All right, let's see. Okay, let's see. All right, so let's look at build applications. No, my files. Personal projects. Code snippets. Okay, I'm gonna let it load for a little bit. Looks like it's recovering quite a bit. Let's say original. Thanks for coming by, Liza. Hope you have a good night. Yeah, I think I'm gonna call it for today, though, guys. I'm gonna see if I can do some of the data recovery off stream. Might have to look through some things. I can't really commit right now because the files are gone. But hopefully next stream I'll have everything set up. Sorry about the abrupt end for today. Just me being silly. I did push my Pong code, so that was good, I guess. But yeah, I should be on stream tomorrow. Right about 1 p.m. I usually stream pretty long, so I'll see. But yeah, thanks for coming by if you're on stream. Hope you have a good day or night when you're watching this. And if you're on YouTube and you're watching this, hope you have a good day or night whenever you're watching this too. Yep, later, Sionix. Bye. Alright, later.